It's not that there's no globe evidence. It's flimsy once you start scratching at the surface.
But this is not evidence, Jeremy. All they have is mathematical equations. This is not evidence. They don't have geometry.
I mean,
the bar has to balance.
It looks good. Chemo, it looks good on the surface. From what you're taught, what they tell you, it looks good. Once you start digging, it doesn't look so
what
hot
looks
anymore.
good? Tell me what looks good. What looks good?
The things they say.
Like your name start with one thing. One thing looks good. What looks good?
They say they have geometry.
That looks good.
Then you start digging. Then you start digging, and you realize they don't have geometry. That's what I'm saying. Once you dig down, it's not there.
Yeah,
but that doesn't look good. That's not good. Just by saying gravity, geometry, refraction.
Shut up, Chemo. Jeremy, debunk trigonometry right now. You just made a statement, and you've got to put in because.
It was just
when you dig deep, it's not there. Where? Show us right now.
It was just a test.
Fuck me, this geezer.
No, it was just a test to see if we would get triggered, that's all.
Yeah, but Kosher, let Boonan have a conversation with Jeremy. Why did you prevent that? This is
Chemo,
what I'm
shut up
about.
so I can have a conversation with Boomer.
Yeah, but Booner's asking Jeremy a question.
Until he was done. Don't interrupt me to say that.
Yeah, but why can't he ask Boonan Jeremy a question?
Ask him whatever
it's
he
like
wants.
No one's taking Boonan. They don't take you seriously, Boonan. They think you're
It wasn't a very
well
worded question. He just said, debunk trigonometry now.
Jeremy,
even the globe Earth is not taking Boonan seriously.
Come on, dude.
But Boonan, your question is not very important.
Everyone has a different style. You just gotta respect each other's styles. That's all.
What's your style? Allowing people to tell people to cut themselves in the text chat over and over again.
My style is calm and adult-like.
Ignoring toxicity and allowing the cult to prosper. Is that your style?
You are the most toxic person in the Discord right now, Don. You literally are the most toxic person. So I really
see what's happened,
No,
Boonan.
I'm not.
Look
I'm
what's
not,
happened. Jeremy and Boonan were talking about geometry, and Kosho and Mr. Scott are doing their best.
Oh my gosh, it's almost like it's an open group chat.
Trigonometry.
It's almost like everyone can talk.
Don yelled at him for something. I said one thing to him, giving him advice. I didn't say don't do this. I was just letting him know that I said don't fall. I said he's just trying to trigger us or whatever.
Right.
I didn't say don't talk to him. Don fucking started yelling at him, but you fucking talk to me and Scott like we're doing something to Boomer. Boomer can talk to him once.
Well, first of all, we're not. I can't debunk trigonometry. Why don't you give me some globe trigonometry and then we'll go from there, Boomer.
Falsify the method.
Boonan, he's asking Boonan. He's speaking to Boonan.
They're red herring it.
It's Boomer, but I'll let you sound silly. No, you made the claim. I don't have to debunk the claim. You have to debunk the trigonometry claim that it doesn't work that you made. That's all. You've made the statement. Now back up your statement. Thank you.
Yeah. I also want to hear it.
So in other words, you have no globe trigonometry.
No, the point is, Jeremy, the point is that you said the trigonometry doesn't work. Now you're changing to the globe trigonometry and asking for numbers. So does trigonometry work as trigonometry?
I never said trigonometry doesn't work. Never said that.
Oh, okay. I don't know. I just got the impression that we couldn't use trigonometry because it doesn't work, or it's a made up indoctrination
He
from
said
the globe.
he said we don't have geometry is what he said.
Yeah, so now we've got no geometry. Okay.
Yeah.
This is what I meant
For the
about
globe, obviously we can do geometry, obviously, but we can also do trigonometry, lots of stuff.
Then we can apply it to the globe.
So Boonan, does that answer your question?
Apply to the globe, yeah.
Boomer, does that answer your question?
Give me some geometry or trig that you've applied to the globe.
Like Eratosthenes, whatever his name is.
Who?
So Eratosthenes uses geometry to figure out curvature.
Eratosthenes?
Yeah, that guy. Yeah, I have an issue with his name. I don't know why. Eratosthenes.
Aristophanes.
The Rosti guy. The Rosti.
Or when we use trig to figure out, say, like distance to the moon, or when we use geodetic surveying to figure out what the curvature of this sort of certain area is. We use trigonometry to figure out stuff about the globe all the time.
First of all, I mean, I can go in for an hour on Eratosthenes.
Well, there's no need.
I somehow doubt that.
There's no way.
I'm sure you can make noise for an hour. I'm sure you can make
so many things.
Could you say anything that was actually compelling that actually debunked my doubt?
Why don't we just go back to the trigonometry and then him giving you evidence that we have trigonometry, and we'll just go from there. We don't have to talk about Eratosthenes specifically. To know the distance around any latitude, like the distance between any two lines.
I think this should have been more productive if Boonan and Jeremy could get through the points, Kosho, Mr. Scott. Why won't you allow them? I mean, it looks like you're trying to give an answer and then end the conversation. Boonan and Jeremy were having a conversation about trigonometry, and now they're not.
No, he didn't.
Kimo, stop being obnoxious. Just let people talk.
Boomer said that Jeremy had made a positive claim and needed to provide evidence for that. That was it. He didn't need to get involved.
Right, evidence, Jeremy.
He came back in to say, "I don't need to get involved."
Jeremy, what's the evidence for no trigonometry?
I mean, they're trying to make angles to objects that they don't even know the position of. Which you can't make you can't make an angle to an object that it looks like it's there, so that must be where it is.
Boonan, did you hear that? He's saying that. You've got objects that you're using trigonometry to where you don't know where they are, right?
He doesn't need the commentary. Thank you, Kimo. No, Jeremy's original thing he said was trigonometry looks good. Then when you dig deeper, you find it doesn't work. Okay, Jeremy, you've dug deeper, obviously, because you said you have. What were your findings when you dug deeper? Where did you find it doesn't work?
It doesn't work when you're trying to take the angle to an object that you don't know the actual location of. The sun, stars.
Why?
So you don't know what you're doing with it, is what you're saying.
No, here come the ad-homs. Conversation is now over. Boonan, why don't you answer Jeremy's question directly?
Can you stop doing that, please, man? You're the only one obstructing the conversation. Please stop.
Yeah, really, Kimo, you really are.
Yeah, no. Shut up. Boonan asked a question to Jeremy. The Boonan obviously wants to find out why it doesn't work.
Kimo, just let people talk, please.
Spurs, it's fine, mate. Just let it flow.
So, Jeremy, what's the problem with that?
You can't make a triangle if you don't know the top point.
You don't have to make
Please elaborate on that.
You can just measure an angle as well.
You can't get an angle without a top. You can't get an angle without a top point.
Yeah. Hold on, dude. You have no idea what you're talking about.
Imagine I have imagine I'm trying to draw a triangle on a piece of paper. I got two dots on the bottom, and I don't know where to put that third dot up top because I'm not sure where that object is.
It really doesn't matter where you put it, though. It's still a triangle.
Or is that?
Well, okay. I mean, it's going to matter where your angle is going to matter.
Yeah. You know my point. You know exactly what I was going to say, D. Go ahead. Do it.
No, if you put a point above those 2 points, you have a triangle.
You have nowhere to put that point, though. You don't
put it wherever you want. It's still a triangle.
Hey, D20, can Curve please answer it? I'm curious to see how it's done.
All right.
Oh, no. Got it.
Go ahead, Curve.
No, you're making a good point there, D20.
Hard for me to interrupt you, D. I don't want to be that kind of guy. You go ahead.
Okay, buddy. Okay. Fucking clown shoes, dude.
Hey, Jeremy, maybe at some point we can finish up what you and I were talking about with the bricks.
Yeah, maybe I should get a room.
Oh yeah, that brick thing. I gotta go check on that. I can't believe you. That wasn't while locked up for me there.
I didn't know how to deal with it, Jeremy. So everybody else had to step in. Well, not everybody, but it became
fucking tissue.
But other people had to explain it for me, Jeremy. I wasn't capable of having that discussion with you that you specifically called me, on, so to speak.
Like anything, I did call you out directly on that too. But anything I bring up in here, I mean, I gotta get.
Anybody's free to respond and take over for me. It's fine.
Kev, can you carry on with the trigonometry?
He's too busy being a passive-aggressive Karen to actually.
He was talking about something else. He was talking about something else.
He wasn't talking about you, D20.
Can we go back to the triangle stuff before it got sidetracked?
Yep.
Please.
No, it's not going to happen if, like I say, the moderation here is constantly interjecting and not allowing an organic conversation to take place.
Moderator.
Kev was just about to explain how to do the triangle, and he got sidetracked.
The problem with D20 chipping in was It was
Yeah,
fine.
Right, you're jumping in.
How about everyone shut up and let it flow?
I'll shut up.
Jeremy, you're just measuring an angle from your horizontal, line of sight to the apparent position of the object. You don't need to know how far away it is or anything like that. We're not doing flat Earth measurements. Okay, we're not doing a triangle in that situation where we're measuring the angle of, say, the northern celestial pole above our astronomical horizon. Do you understand that?
Yeah. Not only are you listen, you're you're getting the angle. I understand you're getting the angle to where it appears to be, but that's not where it actually is. You're also presupposing how the sky works in this. You don't know if it's a reflection or what's going on. It could be anything could be going on up there, for all you know.
Who's presupposing it's not where it appears to begin with?
Who's presupposing what?
Your mic's busting up.
You're presupposing. You just made a statement that it's not where it is or where it appears. As if
we know it's not where it appears. That's
you're making that claim.
In your model, it's not where it appears. That's what you guys claim.
For various reasons, but there's a lot you don't understand about that. But the apparent position for me is the same as the apparent position for somebody else on the Earth.
And we hope so.
The difference is, due to where it actually is, and its apparent position due to like time of light travel or something like that. That's what you're referring to, right?
Amongst other things.
Terrible mic connection you got there, Curve. I think you need new Wi-Fi and a new mic, Curve. This sounds horrible.
This is why Boonan.
It has nothing to do with the microphone.
Sounds totally shit, mate. You need to sort your system
Everybody,
out
including Jeremy,
understood him.
This is why, Boonan, Jeremy said the evidence is flimsy. Now, he shouldn't be arguing with Kurt for as long as he has been. If the trigonometry works, Curve should say, "Look, here's the star."
Take Boomer to another room and tell him about this down there.
Here's the star. Here's the angle, and this is how it works.
Chemo,
right?
You're really stopping the conversation, right?
Chemo, by that logic, any time that someone puts up a strong defense against a murder trial, we should automatically let them go because they obviously.
I think we've been over this before.
Well, this is not a murder trial. This is something completely different.
You're measuring your angles simultaneously from various locations to the same apparent position, Jeremy. Your argument fails.
Before, if Jeremy speaks up, I'll stop. I just want to say you might want to bring up the purpose of making those measurements. Because I think when you pin down why you're measuring the angle to the star or the angle to the sun, and you're trying to find it, let's say see what latitude you're on, the actual position and the apparent position are different at the most at a half a degree, and at the least, not out of position at all. In which case, your measurement of seeing what latitude you're on is going to be basically the same latitude. So,
okay, well, what happens if it's a reflection? Are they going to be in the same spot for those people?
See, that's what Jeremy's on about. He's hypothesizing magic mirror reflection.
I'm giving you a way because you say it can only work like this. You guys think the sky can only work this one way, and since the sky works in this only this one way, very specific way that you have detailed, that it can only be a globe because of this.
Hey, curved.
Okay, so Jeremy,
show us otherwise.
Why and how it could be a magic mirror like you're
curved.
Jeremy, let's try this a different way. Because
see, I got 10 Glovers on me. How can I do it? How can I do it with like 5 Glovers?
Yeah, guys, you got to not do that.
There we go now.
Hey, curved.
All right.
Curved.
Can I try this for a second?
Well, it is an open room. I think everyone should be able to speak, not just Curve. So if Sort wants to say something,
come on,
or maybe Brian wants to say something.
Also, hey, Curved, your mic is crap.
Especially your mic is really bad as well, Curved.
Your mic's crapping out.
So, Sort, you want to try and answer Jeremy's question about the angles?
Yes, because do not look at the skies.
Just ask him a fucking question. I just told you this, Chemo. Sort, you're fine. Just go after Brian. Just ask him a question.
can barely hear Brian.
Okay? So that doesn't mean that there's somebody else has a question.
Maybe let the
Not 5,000
conversation
people talking.
flow and stop fucking policing it so hard.
But
Jesus.
can I go on?
Everyone
No,
needs-
just relax,
everyone's gotta calm
Kosho.
down.
Let people speak. Go ahead, sir.
Everyone's got to calm down.
Chemo,
Don't tell me to calm down.
Don't tell me to calm down.
Calm down.
So,
Can I have this talk with Jeremy then? Or are we all, giving our little opinions and things here first? Good. Now, Jeremy, don't look at...
I go ahead and I relinquish my question. Please take over, Sword.
Jeremy, when you look at the skies or the stars, don't look at it like, we have to know where the star is at. If we look at Polaris, we know for every 60 nautical miles we sail, it moves down a degree. And when we've done that for 90 times, we get to the equator.
Why don't you cut yourself? Why don't you cut yourself, you dirty fuck?
What's that proof? You need to relax, dude.
It doesn't prove anything. It doesn't prove anything but the distance to the equator being 90 times 60 nautical miles. And so, that is just, it proves the distance. It proves that measurement of the Earth. Because it is, literally defined that way. And incidentally, when we do that same thing to the sun, and we can do that, we can tell when it's highest in the sky, midday, right? If we do that same thing, when we go 360 degrees around that line of the equator, we get 4 times the length. And those two numbers, 60 times 90 and 60 times 360. Those two numbers, they make it a ball. Measurably a ball. That's geometry for you. And yes, we use the skies to, tell us where we went. But that was, just to have a reference of
10 seconds.
It's just a fixed point to measure from. It doesn't have to be somewhere.
Okay, so now we're done with the trig. We're on the geometry now.
It's not trigonometry. It is.
I know it's
basic geometry. In fact,
yeah, we're on the geometry now. Okay.
From trigonometry to basic geometry, and I proved to you it was a globe, and they didn't need the location of Polaris. I just needed it's there.
Just like
so do you have?
And it seems to stay here.
What was the geometry you had? Sorry.
Well, like I said, it moves down a degree for every 60 nautical miles you go south.
Yeah, but you're presupposing all kinds of shit about the stars and the sun when you do that.
No, there is no presupposition. There is, look at it. Look at the angle to it.
Yeah, but you don't have the exact location, so that's what he's saying. Again.
You're saying the sky works like this and only in this one specific way that I said, so therefore... when I do my trig, it's going to work out to be a globe, but it might not be that way that you presuppose.
That you're in the country you're in because people did just that to get there. That is how they navigated.
Yeah, I don't know what reflections you look at, Jeremy, but they don't act like that. A reflection changes off a watch face in a sun.
I'm not saying it is a reflection. It could be.
So now it's not a reflection.
It might not work. Yeah, it might not work the way you think.
It's a mirroring.
It could be. It could not be that specific one way that you guys have in your heads.
But I'm just asking you. When have you seen a reflection look the same from all angles?
I don't know. You're presupposing distance.
I'm presupposing nothing. I'm asking you to recollect every reflection you've ever seen and whether it changed at the smallest amount of movement from a reflective surface, i.e. a watch face, a mirror, a door, a window as you closed it more or opened it more, anything.
You're saying if you move the mirror, will the reflection move?
Anything with a reflective surface move just the slightest amount will change its complete shape.
If you move the mirror, then you'll change the reflection.
Reflective surfaces.
Okay, whatever, yeah. If you move the reflective surface, you'll change the thing. Yeah, sure. Are you now presupposing that the mirror in the sky is moving? Like, I don't see. That's what I mean. You need to stop your presupposition.
It doesn't matter about whether the sky is moving or not. The reflective angles, it would all be different for every different person because
you don't know how the sky's working. You don't know.
I know how reflections and mirrors work.
But not the sky. That's Jeremy's point.
That's not.
I'm not even saying it is a reflection. It might not be a reflection.
Okay, what's a mirror? What does mirroring mean then?
Stop! You're not the sky.
Look, how can you take your angles if you don't know where it is, sheep? That's his point.
Hold on, Chemo. Go, Brian.
It literally sounds like you're making an appeal for it to be. It is. You're holding this up. You don't know.
You might cut now.
Be breaking up. Barely.
Yeah.
Try that again, Brian. You cut out mid-sentence.
All these terrible mics.
It's just a connection issue.
That's
as long as mine is clear, concise. You can hear me very well, right?
Yeah.
Excellent.
Yeah, well, you're in the studio.
It's not concise though. There's something wrong with it. It's supposed to be concise.
People thinking the Earth is flat is a connection issue.
Now, look, we're going through why your evidence is you don't have any evidence. And Jeremy's, this is just the first thing. This is just the first thing. We have many other points.
Don't save Jeremy. Don't save
this
Jeremy.
Hasn't finished. Hold on. This hasn't finished. We're just going over trigonometry. Once we put that to bed,
you have never.
We'll move on to the next
dropped
one.
Any evidence for your flat Earth nonsense. You have not ever.
This is what we're like. We've got so many points we want to cover. Usually there's not enough time.
Cool.
Like when I was with Mr. Sensible, I mean the amount of topics I wanted to cover.
About you now, is it?
No. I'm just saying that there's lots of things we have to cover.
No evidence. You've not yet ever, to this day, presented one single solitary piece of tangible evidence to support your fucking pancake world. You haven't once.
Neither have you for the globe.
Okay. Let's not get away from your claim, Jeremy, about your possible replacement.
Let's see a tangible measurement. We need a tangible measurement like D20.
We need no white knighting. No white knighting saved from chemo. Let's go back. Let's wind it back. Jeremy, you made a claim that we don't understand how the sky moves. It has to work this one way. Then you also countered with it could be a reflection or mirroring of the sky. Now, what's the longest reflection you've ever seen? And did it change or shrink or change, in any way across that distance? At the slightest movement, did it change shape also? Go.
If you move the mirror?
Any reflective surface. Stop getting hung up on mirror.
If you move the reflective surface, I don't know why we can't say mirror, but if we move the reflective surface...
That's just one type of reflective surface.
Yeah, if we move the reflective surface, then sure, maybe it might change, yeah. I'll give you that. So what?
Okay. So, do the stars move?
Yeah, the stars move, yep.
Right, so the stars move, and they shine, and they're reflected in your idea, yet the shape never changes.
Okay, we'll go with that.
Right. So, now,
the reflective, who said
on a level of 1 to 10, 1 being the worst, 10 being the highest, what is the plausibility of your argument now?
Well, I don't understand what your point was.
You have none, that's my point.
You said we move a reflective surface and the thing changes. Then you said the stars are moving. And then you said I have no point.
Your point was about reflective sky, mirroring of sky. I just went with that premise alone and asked you to concentrate.
Your argument and point wasn't coherent at all. You said, do reflective surfaces, does angles change when the reflective surfaces move? I said, yeah. Then you said the stars move. Then you said I have no point. Like your shit wasn't.
Well, this is about trigonometry. This is about trigonometry. Remember, using stars as a reference point and using only the angle to them. So by your logic, if the stars in the sky, if your stars in the sky, then somewhere on the ground is the star that's been reflected. Yes or no?
Say that one more time.
Based on your premise, of the star being in the sky and it's reflecting, that means the star is somewhere on the ground. Yes or no?
Not necessarily. Listen, not necessarily. First of all, the answer to that is not necessarily. And I'm just giving another option of how it could work. You see how we're
very stupid option.
Hold on 1 second. We're 20 minutes into another way of how it could work. So it might not just be your one way that you think this very specific idea in your head of how the sky works.
Right, but I'm just trying to go through your version, and so far the reflectivity doesn't work, the mirroring doesn't work.
Why does the reflectivity not work?
Well, because something has to be reflecting. So if it's reflecting in the sky, where does it exist in reality if that's a reflection?
I don't know. I'm not presupposing how the sky works. Maybe it's a two-way mirror and the light source is on the other side. Who knows, man? It could be anything.
That's his point, Sheeple. He could just say, you're saying maybe it's a ball. Maybe, you know, we don't know what the sky is. Nobody knows.
All right. Thanks. I'm done with the questioning.
So, Boonan,
I'm happy with
debunked trigonometry because Sheeple can't show practically his explanation. And that's one of the reasons why you don't have evidence. And Jeremy is right to say that you don't have any evidence. Trigonometry is not evidence. We can't apply it.
That two-way mirror. That is, you know, that is nothing in what I said. I said you could see it and you could measure the height of it over the horizon, and that was it. No presupposition. It's just a point that you can see.
Okay, we're on to the horizon now. Is that where you wanted to take it?
That is pretty much how you measure the height of it. Yes, Jeremy.
The horizon again. Jeremy, get them. See?
Horizontal. Doesn't matter if it's horizontal or horizon for navigation.
Yeah. Do you understand his point, Jeremy? If you don't, then I can understand why you said horizon.
Well, we're now talking about the horizon.
No.
Is that really what's his point? Why don't you sum up his point for me?
His point was about Polaris, which is again in your reflective two-way mirror reflecting, you know, mirroring sky thing that you came up with, right? So the fact that you move away from it 69 miles, you go 1 degree down, and so it goes off the horizon based on your, towards the horizon, and lower and lower and lower to the equator till it's at the horizon. That's the only reason for horizon. Now, again, this phenomena is seen from every single angle in the world that people look at Polaris from. So that's why I'm asking you, this reflectivity idea doesn't hold any strength in any type of plausible replacement for what we say it is, because reflections don't keep their shape. They change.
So you said we had a phenomena. That's good. Sounds like we're about to do science now. Or do you have no science?
Does anyone else know where I'm going with this?
Wait, do you have?
Well, we need a summary from Boonan though, Sheep, before you move on, because it was his question about trigonometry.
Yeah, he already stated what he wanted, and we're doing that. Why are you going back into it?
Because now you're talking about science.
We moved it from trigonometry to symbol geometry and geometrical navigation, and that is it. You know.
All right. What's the geometry?
The geometry is that for every time you move 60 nautical miles or 69 miles or 110 kilometers south from Polaris, it moves down a degree on from the horizontal.
This is trigonometry. This is not
right. And that's south in any direction, right? From any point.
From the North Pole and southwards, yes.
Exactly. So any point, Jimmy, and that's the point that I'm trying to make. Your reflectivity mirroring sky idea makes no sense, because what is directly below you, what is above you when you're at the North Pole is Polaris, you know, almost not even a degree off. And so if it's reflecting, is it reflecting off something on the ground or something in an unknown medium above through a dome reflective two-way mirror, security mirror type thing for no reason at all?
Yeah, it could be any of that. Yep.
Yes, but in that whole thing, you know, no, because all I needed to say was there's a light in the sky and it's pretty much fixed right there.
Yeah.
What is it? I don't know. Why does it stay there? I don't know, but it does. And when I move away from it, the angle changes by that correlation that is absolutely established. That is all. I have no presupposition in this. I just have a freaking observation.
Your observation is apparent sort.
It does not matter. It is observation everywhere on the freaking northern hemisphere.
But you may as well say a hologram or an illusion. You're not measuring the actual star.
What meaning of apparent? Kimo, can you specify what meaning of apparent you're using?
Yeah, but you're not measuring the actual location, are you?
Yeah.
There's a few meanings of apparent.
Not actual.
Hey, Jeremy.
Why is that needed?
Jeremy was learning something in Kimo.
Because,
Jeremy,
let's say you were trying to measure...
You just had to be explained to you. Hey, Kimo, shut up. You're trying to stop him learning. Just because you're a dumb fuck. Jeremy, you actually got something to mull over and digest there. So you see how, as you dig in when it gets explained, you get the right questions, and you don't listen to people like Kimo or QE, you can actually grasp another piece of the jigsaw puzzle. You actually learn something. Thanks, Sort.
No,
Thanks,
I get the explanation for it. Yes, you move 69 miles, 1 degree or whatever. I understand, but that's based on the heavy presupposition of how the sky works.
No, that is based on it happens. That is the observation, Jeremy. It's not based on
if you were trying to figure out the height of a tree, you wouldn't figure out the apparent location or the apparent height. You'd figure out your triangle perfectly, so it fits, and not any apparent. You get the actual
height of the tree would work too, Kimo.
But Kimo navigation does not rely on the height of the Polaris. It relies on it being a spot in the freaking sky that stays where it is.
No, I'm just saying if you had a star, a Christmas star, top of the tree, you would have to get the actual star, not the apparent star.
Shut up. Do you navigate by the freaking Christmas star in the tree in your local, I don't know, courtyard, whatever?
If you put the North Star on top of my Christmas tree, then the Earth is flat.
It's so stupid, Kimo.
Fucking idiot.
If you put the tree trunk and use the distance back from the tree and then the angle to the top of the tree, you could measure the tree. What the fuck are you talking about?
Yeah, but then you would know the location of the top of the tree, right?
The idea that the Earth is flat is a reasonable fucking proposition. It isn't. So why the fuck is this even a conversation?
Oh, but that rolls off a swan's back.
A black swan?
I mean, as long as we're looking at things through the atmosphere, everything is an apparent position. I mean, the apparent position and the actual position are generally very close to each other, but nothing is its actual position. Everything's being refracted.
Is the star even on the tree, or does it look like it's on the tree?
Is there on the tree?
I'm just wondering, if we don't know where the location is, then we can't even verify it's on the tree. It just looks like it's close, and now therefore it looks like it's on the tree. You have to know where things are at.
The fact is,
I think the trick is that we take their apparent position as where they're at, and it works out. Because the differential is so small that it never really matters much.
Exactly.
How do you know it's only a slight off if you don't know where it's at?
Well, actually, Sheeple explain to her, Stacy, about because I brought up the tree. You said that was a silly analogy. Hold on a second, Mr. Scott. So Sheeple,
we're talking.
I think she was asking Scott a question.
Yeah, but Sheeple said the tree analogy was a bad one, and Stacey's like, well, I like that. So can't we explain why knowing the size of the tree, the location of the tree is a bad analogy?
How the fuck are we talking about trees now? Come on.
We're talking about the star on top of the tree. Yeah.
I'm not talking
about is the flat Earth community's absolute failure to prove that the Earth is flat.
Your analogies are just bad.
I'm not talking because it's cutting off what was being said before I was asked a question by you, Kimo. So please let the conversation carry on for now.
I'll be brief, Kimo. I think the trick to it is that if we were wrong about it, if the apparent position, say the tree, and the actual position, if it deviated too much, then when we do things like build something to it or try to drive past it, narrowly missing it, that would stop working, or that would not work as reliably as it does, and we'd have to realize, okay, things are actually more displaced than we realized. We'd adjust for it. But it turns out that they're so close to each other that we can actually get away with even driving a car like right within an inch of something, and it works out.
Now it's convoluted.
The key is that technically anything we see through the atmosphere is potentially displaced in some way or another.
Via refraction, or it's not even actually there yet because you say, yeah, we know it's not in. You have no triangle. This is what I'm saying. You have no triangles because you don't know where to put the top dot on your triangle.
We just use the apparent location as the actual. But if you hold on, Detroit, if you think about it, everything you've ever measured, Jeremy, everything you've ever done in your life, what you're looking at is an apparent position.
No, I've measured a 2x4 before. Hold on. I've measured a 2x4.
I know, but you're looking at the apparent position.
No, I've measured a 2x4 before, and I've taken its actual position.
But you can't take its actual because you're looking at it through the atmosphere.
No,
that's nonsense.
I've gotten an actual. You're saying you can't get an actual position on something?
Mr. Scott, hold on. Let me explain something here, Jeremy. So, Mr. Scott, this is pure nonsense. Are you saying that when they calculated the distance to the moon, it wasn't the actual distance to the moon?
I'm saying that nothing is the actual distance to anything. Yeah.
So how do they work out then how much fuel they... Mr. Scott, if it's not the actual distance...
I'm saying that even when you take a measurement, the precision that you're going to take it at isn't going to be perfect. So everything we ever do for anything in terms of the real world is an approximation. We're never, ever perfectly accurate. So we approximate our lengths, we approximate our measurements, we approximate our positions. We approximate our positions. All that stuff is approximate. Now, the approximation is incredibly good. It's very, very close. So it's so close that in an actual practice of our lives, it doesn't seem to make a difference. But it is not. It is important to know. It is not precise, 100%. It's not the exact right thing.
Yeah, well, again, that's not the way to go about knowing things. It means, just like Jen would say, you are ignorant. You don't know anything. You don't know the actual distance or how to figure out the actual distance because you believe you're in a simulation and looking at an illusion all the time, Mr. Scott. That's not an honest way. That's not an honest way to go about.
No, but it's the opposite. The simulation would make it so you could get the exact stuff. It's in the real world. We're treating it like in the real world.
Mr. Scott.
Just think about. Hold on, let me finish before you interrupt. Just think about like a ruler. That ruler is supposed to be 12 inches long, but is that ruler exactly 12 inches long? I mean, is it 12 inches to the micron?
Yeah, every ruler in the world that is 12 inches long will be 12 inches long.
But you know that you can't build a machine that's so precise that it can make a ruler so perfectly 12 inches that it's down to the micron.
But wait a minute.
Now, the micron level is going to be slightly off.
That same ruler every single time to measure and cut everything, it's going to be the same fucking size.
Right.
Well, but yes, but you can't get it. You can't get it down to the micron, right? So
what are you talking about? The right one, Mr. Scott. We're talking about 12.
Why do you keep interrupting?
Because you're talking about something else. We're not talking about 12 microns. We're saying either it's 12 inches, 12
I'm making a point. That's the point I'm making. Is about 12 microns. Everything is approximate.
Precision. Level of precision. Done. Argument done.
Simple. And Chemo, I got
12
your picture
miles
here
is
for
12 miles. 12 meters is 12 meters.
Chemo.
In theory, in abstract it is, but in practice you can't quite get the perfect number. You can get close to it, very close to it.
Right, we're just gonna.
It should be common sense.
How far out in space and all the way back, but we're just, we're not. We're just doing approximate. You know, we don't know precisely where the Earth is, or precisely where things are at, but we're gonna land it on how many miles away.
A lot, like 400,000. But if we know if the approximation is very close to the actual, if it's very, very close, then it'll work out, right? Like, let's say it's only off by fractions and fractions of a micron, right? Well, then it'll work out because that won't make a difference in the kind of stuff we build.
How do you know you're only that tiny bit off if everything's in a parent location? You don't know any distance. So if you don't know any distance, how do you know how much you're off?
No one's traveling to Polaris. Don't worry about it.
Because in practice, everything that we do works. So when we build things, we're not crashing into stuff. So we can tell.
Therefore, you know that it has to be that far, and how much you're off.
Because it works out. Because it works out, we know that our approximations are pretty good.
How many ball earthers are here today? Lots and lots of ball earthers.
You go, Chemo.
We don't know it to absolute precision. Does not mean that we don't know the distance at all, Stacy. You're making a huge fallacious leap there.
No, to me, a distance is exact measurement, not like, oh, we think we know. And if it's an apparent location, wait. If it's an apparent location, you'd never know that position.
But Stacy, when you measure something, do you get it perfect, or are you off a little bit?
Well, it depends what I'm measuring with, and it depends what I'm trying to measure, but I don't like to measure too much shit, so therefore, not really, don't care about that. You're talking about what I'm trying to say here. It's an apparent location. No matter how many times you measure that, you're never going to get it correct. So refraction's always the same. You're going to see it the same way every single time. How are you measuring everything correctly every single time you measure that?
So you're not, though. That's the whole point, is you're not measuring correctly. You're getting close, but you're not getting perfect, ever.
So how many times has it been measured, the distances of places, and how many times has it been off?
Every time.
Well, every time you measure, it's going to be off a little bit. But it might be off. Like, here's the deal, though. It might be off. Let's say you measure something 10 feet away. The amount that it's off by is going to be something on the order of like 1/1,000,000th of an inch. Okay, so such a tiny amount that it's off by. That it makes no difference on the scale of 10 feet. Hold on, Chemo. It's really unhelpful when you just start interrupting and over talking. So the level that you're off is so small that it doesn't really make a difference. That's why it kind of all works out anyway.
While you mods are discussing measurements, there's people in the text chat telling people to cut themselves and harm themselves still.
Yeah, right, okay, whatever.
That's horrible.
Just thought I'd let you know again.
Can we put an end to that? Can we put it into that?
Worse, Jim. They said worse.
Can we just keep that in the chat then?
Just while the mods are talking.
Cosmonaut, please stop it. You know this causes fucking problems that we then have to sort out. How many fucking times do we have to go through this childish nonsense?
Oh, they're really doing
I've got stuff I need to do, and I cannot be doing with this crap.
Yes.
What's going on?
It needs to end. It's ridiculous.
Thank you for saying something, Jim.
Okay.
As well, bringing me this bullshit. Really, just...
We're just having banter. I have to bring you the bullshit because it's very toxic and it could get your server shut down.
Don, you got to stop doing it too, though. You have to stop doing this also.
I don't tell people to cut themselves ever.
Yes, you
He hasn't said that.
I don't do that.
He hasn't said that. And you say much worse than that.
No,
and you did say
I don't say stuff like that. I don't do it.
Servers not getting shut down over some nonsense like that.
Can I ask a question real quickly about a fallacy? For instance, how do you know it's only a tiny bit off if you've always said from the get-go you never know where it's at? So if you never know where the location's at, how do you know how far you can be off?
A very minimal amount.
This is kind of your thing.
But if it changes every time, right, and it's an apparent location and you never know where the position's at, you can't verify how much you're off.
Okay, so pick a point and say that's the central point of absolute accuracy, and then accept that every time you make a measurement, you're going to be to 1 or 2 degrees to the left or right of that central point of accuracy, because having a 100% accurate measurement of anything is literally impossible. It's chaos theory. There's variables.
Okay, but there's that. Then there's also measuring an apparent location on top of that.
I don't understand what you mean. What do you mean, Mary?
Well, you know, you just said earlier everything we measure even on here on Earth is going to be a little bit off. So therefore, you're trying to say it's going to be a little off on the math in general because nobody can measure to that degree. However, also we're measuring apparent locations with math being off.
But listen, what I'm saying is that the idea of having an absolutely perfect measurement of a thing is not possible because of variables. Things around that, outside influences, change that measurement by a minimal degree in either direction. So you can never have a 100% perfectly accurate measurement of anything ever, anywhere, period.
Scott was talking about.
Always going to be, yeah. That's what Scott was trying to point out, is that you cannot have perfectly definitive, accurate measurements of anything.
Well, think about this, D20. If you had the actual location, that would give you a far better measurement than the apparent location, right?
Wait, if you have an accurate location,
no,
it's better than the
actual location than an apparent location. Your measurement would be more accurate with the actual location, right?
Right, but Chemo, you're a smart dude. You understand that measuring a thing always has to account for variables, meaning that you can never have a perfectly accurate measurement of anything.
I'm not on about the perfect measurement. I'm talking about the location, knowing where something is.
Yeah.
Yeah.
Okay. Well, so for something like that, we usually have a sense of what the error could be. So we have this sort of range. We know that it might deviate from true. We can get that from a variety of different ways. In the case of refraction, we get it from an understanding of how light bends, what causes it to bend. And so if we know sort of how it can vary, then we can have some guesses as about how off are we. That's really the key to engineering. It's not so much to get things perfect; it's to know how off you are. As long as you know how off you are, then you can sort of account for that mistake error, that error. Right?
How can you know how off you are if you don't know where the actual location is?
Yeah, because if you know why it's being displaced, say because of refraction, and you know how refraction works.
But you guys don't know how refraction works. You guys claim that you guys know how light bends and it can bend a certain way, but can't prove that. So therefore, how can you guys claim that you know how light can bend in manners out in outer space?
Well, we do. I mean, not we, but mainstream science has a pretty good understanding of how refraction works. When you say we can't prove it, I don't know exactly what you mean.
No. I'm not saying you can't prove refraction. I'm actually just stating you guys actually understand refraction. And then you're going to understand that light can bend in the manner that you guys are saying can be bent, yet you have no way of proving that.
We know light exists, but light can't see.
Sorry, Sheeple, couldn't hear you there. Say that again, Sheeple. Couldn't hear Sheeple, for goodness sakes.
I spoke at the same time as
Stop it.
Yeah, they speak at the same time.
Stop it. Scott, can I ask you a question before the subject gets changed again to something different than what we're talking about? Because you guys are talking about precision, and then someone's talking about the variables of this position. Why are we talking about where the object is? Is that important in these observations? The actual position, the actual location of the Polaris, or the actual location of the sun, is that actually irrelevant at all, or just a visual? Or just
just actual position is definitive.
It's important, Kosho. It's important.
Christ, for fuck's sake.
I got your point, Kosho. We got it. Is it important to know it?
Chemo, stop it, Chemo. Stop it. You're really being obnoxious. Just let people talk. Come on.
Important the actual location of this object, or is it important the visual position that it is, like visually in the sky? Because to me, that's what I always thought, that it's just the visual position in the sky and how that's changing and it's affecting the ground.
That's right.
I think we were talking about else.
Yeah.
No. The point was that your trigonometry and your geometry, all your numbers, don't correlate in reality because you're just measuring an apparent position. That's the point. That's how Jeremy premised this. Is that you're not actually making measurements. You're just, like Mr. Scott said, you're guessing where the stars are.
Oh, we're
your best guess.
It was an angle, Chemo, for fuck's sake. And here's a question: can we use GPS? Can we use GPS?
It's not a guess. It's not a guess. It is mathematically viable. But there is always.
So hold on, let's look at it if it's a guess. D20. If you're looking at the apparent star and not the actual star.
I guess I was finished with the fucking sentence.
If you're looking at the apparent star and not the actual star, well, where is the actual star to make your measurements from? How can you model?
We only need the apparent star to make our measurements. We only need the apparent star's position to make our measurements.
Okay, but then where is that star?
It doesn't matter. We only need the apparent position to make our measurements.
I don't think this is making. I don't think this is sinking in to you guys. So that star,
I think it's sinking into you.
The star that's apparent.
Does that apparent location change?
The apparent location,
absolute definitive location of objects, millions and billions of miles away from us, with zero margin for error. We have to have a fucking absolute zero error fucking understanding of the location of that thing. Otherwise, it's then magically apparent and therefore doesn't really exist.
Again, it's not about anything that has to do with anything about that or its position at all. It could be a beetle in the sky. It doesn't matter what it is. It doesn't matter where it actually is. It is we're trying to measure the Earth, and then we're talking about is the Earth. And so we're using these things that are in the sky because of the way that they appear to be is giving us some idea of what's happening on the ground, and it's giving us.
But why aren't we just focusing on the ground? What we're standing on that we can actually measure instead of what we can't see in the sky that's apparent locations. I mean, for the heaven's sakes, we're on the ground.
We do that too, and this is a way of doing that.
Don't just say apparent locations.
It's cross-reference.
It's absolutely understood where all the other planetary bodies of the solar system are at. Now, if you wanted a micrometer measurement of distance from here to there, sorry, we probably can't give you that because there are so many variables. But the fact of the matter is we know where Jupiter is and Mars and Venus, all round planets, by the way. It'd be pretty fucking miraculous if there's just one fucking...
Well, you know where an apparent location of it is. Again, we don't know how far it is exactly or where it's at.
You need to understand what apparent location means, lady.
You know exactly where it's at, for a fact.
Like,
you know where it's at?
You
You're
need to
seeing a light, you're seeing something in the sky, and you can verify where it's at. An apparent location does not mean you can tell me exactly where it is.
When an aeroplane is at 40,000 feet, that's not the apparent location of an aeroplane in the sky. We can tell you exactly where the aeroplane is. We can pinpoint the location of that aeroplane, helicopter, drone.
The apparent location of something.
Okay, Chemo, you say that's an exact location of that airplane based on the altimeter, but is it exactly down to the micrometer measurement 40,000 feet above the surface of the Earth?
No.
As the topography underneath it changes, it's just always exactly 40,000 feet?
No, we will know if it's not 40,000 feet. So if it drops to 35, we will know. We will always know its exact location.
What if
not the apparent
40,000?
Not exact.
It is apparent.
It's not exact.
It is never exact.
If a helicopter is hovering at 10,000 feet, we will know it's hovering at 10,000 feet exactly.
The vibration of the blades alone would make the in and out of accuracy all the time.
Absolutely. There will be variables, tiny little things that change that measurement in a very minute way. There is no exact measurement of anything, period.com. Why can't you understand that, Chemo? That you cannot have an absolutely accurate precision measurement of anything.
For example, in 9/11, if they didn't know the exact location of those buildings, they would have missed.
Not exact.
Jeez.
It's not exact. Oh, did they bomb the fucking bathroom drain or did they bomb the building?
The building. They were heading for the building. They didn't have an apparent location of the building. They had an exact location.
They did. They had an exact apparent location of the building.
It means nothing.
When any pilot lands his plane on the ground, he has an exact location where to land the plane.
No, he doesn't.
The exact location of the ground is...
He's got a runway.
When a helicopter lands on the helipad H, they have an exact location, not an apparent location, the exact location of where that helipad is.
Well, they absolutely, all measurements are apparent.
It's so...
Period.
It's so funny.
There is no such thing as an even the fucking pyramids have a millimeter of error in their fucking construction.
But we know where the pyramids are. We know the exact location.
Yeah, I could travel to them, touch them. We can go to them. Like, we can't go to Jupiter, go and touch it. Like, come on.
A fucking spaceship.
That's stupid. That's just plain stupid. You don't have to touch it.
No, the point is we can verify these locations, right? You cannot verify where Jupiter is.
Yes, we can verify.
You can get an apparent location of it. Refraction, all these things, the atmosphere that you're looking through, and all this shit you guys claim.
We can film the moons. We can film the moons of Jupiter too. But you don't seem to think that's very cool.
According to Chemo's definition, we have an exact location of Jupiter.
No, we don't have any locations of these celestial bodies. None of them. Where are they?
Exactly where. Point up in the sky and go, there it is, right there exactly.
You see there, it's not that hard, because if you know exactly where the pyramids are, you know exactly where the North Pole is, and it's gonna be directly under the frickin' Polaris, then you have two locations, don't you? You can measure the distance between them, can't you? If you can measure that distance, and say something about this,
when you've got a sizable distance between apparent location and actual location, and you're trying to view something, like do a telescope, and you've got that disparity due to the time of light travel from the object you're viewing, you damn well better be able to locate its apparent position, because looking at its actual position isn't going to give you jack shit if you're zoomed in on the fucking object. You people are fucking crazy with this shit. You don't know what you're doing with it.
You need to fix your mic curve. It's awful.
I understood you perfectly. You're fine. I swear I understood you. Didn't miss one word.
It's okay. We just need to know where it apparently is, not exactly where it is. Okay, I get it.
I don't want to repeat it again, but I'm going to try to, and hopefully somebody could take it from there. It's very important that we're not talking about. It's not relevant where these objects actually are. The only important thing is that they appear to be like they move at this constant rate, or they move at this rate that's nearly constant, and we can use these objects to infer what's happening on the ground.
Yeah, it's so you can presuppose.
But it's not the actual location of where these objects are. It's just where the apparent position of these objects are, the angles that we can make.
What I've understood, Kosho, is that you guys need these things in order to have your fantasy. So you need apparent in order to make your measurements. You don't want the actual location, because that means you'll have to have an actual measurement, which will go against which will go against the actual measurements, right? Your presupposed measurements.
I can walk outside right now using my index finger and point at Jupiter. I know right where the fuck it is. Can I give you an exact measurement? No. But I know apparently where it is because I'm fucking pointing at it in the night sky.
Just do what normal people do and measure it.
Right, and you know how light's bending, and you know exactly how much refraction and everything when you're looking up at that sky, right? And you know how it's working?
Yes, we don't have to do.
What don't we know about light, Stacy?
Wait, hold on.
You guys don't know a lot about light, but claim you guys know a lot about light. I'm not even saying that I know. I'm saying that scientists don't know shit about light.
You only think that we've seen these from the atmosphere.
Don't know shit about light.
Hold on.
Yeah, let
D20. Can you explain this chat to Stacy? I'll just post it in the chat.
Go ahead, sir. We're driving around too right now, so just bear with me.
Chat to her real quick. Hold on. What's this chat?
Chat.
I'm sorry, what?
The chat.
Oh, a chart. Like C-H-A-R-T.
Ah,
is that what you're saying?
It's a chat.
Chat. Yeah.
Oh.
It's just the way it's okay.
So we don't know about light, but we know there's all these different things. Can you explain this?
The spectrum.
Yeah.
Light spectrum.
No, you don't know how light works in reality with the refraction that's bending around your board.
I just kind of want to focus on the visible spectrum part and look how much more about light we don't see but understand. That's kind of my point.
You're straw manning here, Sheeple, because we're talking about the extreme light bending that you claim happens on the board. How do you know this to be a fact? Not what light is.
D20 was trying to say something. I don't know what it was because you cut him off.
People are talking, for fuck's sake. Please, manners. It's been good up until now.
You're straw manning Stacy. We have to point that out. Because she doesn't have to answer that, Sheeple. That's the point.
It's not a straw man, Chemo.
You flirters like to use all this little, all the little math things you picked up in your arguments to try to dissuade people from understanding literal science. Okay, I can go outside. I see Jupiter in the night sky. I can look at it through a telescope. Does my ability to measure the exact inches between where I'm at and where it's at change the fact that it exists? No, it doesn't. It's there, and I know where it is at any given point of the year based on astrological forecasts of how we understand how the fucking planets move around us without absolute precision. It's a rough estimate.
No, I'm just saying it's based on the presuppose what you think is that we're on a ball. But you're not even trying to sit here and think, hey, could it be flat? And then doing these same observations. You're automatically claiming it's a ball.
We do, but it's not flat. We've done them.
Why would I think it's flat?
Making observations.
What?
Making
Why would I
observations.
think it's a ball?
Making observations on how the stars move does does not assume any shape. Making observations of the sky does not presuppose any shape. You could make observations on any shape object in space, and those observations are just as valid. It doesn't.
Okay.
It doesn't presuppose a globe.
Yeah, no, but when you presuppose how this
it does presuppose a globe.
Jeremy.
Other planetary.
Hold on, D20.
No. Just making the observations doesn't presuppose any.
Hear Jeremy?
When you try and work out the relationships from those observations, that's when you can work out the shape. That's why observing the sky is important, is valid.
Bazar, do you hear Jeremy?
If I observe fire, do I have
like
to question whether or not that's fire? I'm only
I'm
observing
just
it.
waiting
Maybe
for him to get done.
I'm done, fucking idiots.
I don't want to talk over people, Chemo. So when they, if two people start talking,
but if you don't remind them, Jeremy, they'll just steamroll you.
Go, Jeremy. Stop being a victim. Go.
So you take these measurements, right? And then you're like, all right, it's a globe. We see because of these measurements. But if the sky's not working like you think it is, it might not be a globe.
No, I'm using this, Jeremy. I'm using the same argument you use on the flat Earth side. Is that you come out your front door and you look at a flat plane and you go, observationally, the Earth is flat because that's what it looks like to me. But I have used a telescope and looked at other planetary bodies, and they all appear to be fucking globular in nature. So why would I think that all the other planets would be round, but this one's fucking flat?
That's a terrible argument, D20. Are you really taking it there?
That is a terrible argument. That is like years old.
It's not. Yeah, it's thousands of years old. It's when we very first observed other planetary bodies and realized, oh, maybe this is round also because everything used to be.
All right, here's what I'm gonna do, D20. I'm gonna paint a shape on the ground, and then we're gonna be in a room. I'm gonna paint a shape on the ground, and then I'm gonna paint a whole bunch of shapes on the ceiling. But you can't look at the ground, but I want you to look at the ceiling and tell me what you're standing on. All right, we can do this right now over voice chat. Do you want to go further, or do you want to just end with your silly argument?
Keep on climbing down that dumbass rabbit hole.
Oh my god.
If you were sitting in a chair in the middle of that room and the chair was rotating, you could absolutely do that.
No, he's going to put a shape underneath.
Or the chair was stuck on a globe and it was rotating. You could absolutely do that. But if not stupid argument, you could absolutely do that.
Yeah.
If you
you're missing the point then. He's saying
you're missing the point.
Put a shape under his feet and then put shapes above his head.
Give me a second to finish up. Jeremy gave me a proposition. If you paint some shit on the ground and then paint some shit on the ceiling, what you're presenting to me is a bunch of two-dimensional images that you've painted on flat.
Yeah,
I'm going to make them all. I'll make them all 3D. I'll make all the images 3D.
Oh, how are you going to make them 3D?
Yeah, he's got a 3D shape underneath your feet. You're going to put 3D shapes dangling above your head.
As fun as this.
Okay.
You're going to say...
What shape is...
going in the right direction.
3D image under my feet. Is it flat? Is it?
You'll never be able to know because you're never going to look down on it. You'll never be able to look down. You can only look up at the sky.
Yeah.
Oh my goodness.
That is the dumbest shit I've ever heard.
That's what you're saying, T20. That's how silly it is.
No, Jeremy.
Argument, you fucktard. That is not remotely even.
You're getting angry and violent. Why don't you just cool off for a minute?
Angry? Oh, am I terrifying you with my logic?
Go and throw some cold water over your face. That's a terrible argument.
It's not
Jem was taking it in a great place. I think Jem picked up a D20 had and was taking it to where it actually was supposed to go, which goes back to the argument of why you need an apparent object, why it's the only thing you need, and not its actual position.
Yeah.
I don't know if Jem wanted to continue with that, or if somebody else wanted to go about the fact that you're rotating a chair and you're looking at
it's
it.
Okay, I'm kind of busy.
I think it's necessary to kind of focus on the importance of that chair and its location. It's the same as the importance of the observer's location on the planet. At the speed at which we rotate, at the time at which we see the stars, and the duration with which we see the stars is dictated to give us results that have to fit simultaneously from every observable location in the sky, both in the north and southern hemisphere locations. And rather than presupposing a ball, the only shape that works is a spherical object, or an oblate spheroid the size we are, spinning at the speed we spin. That's the only shape of known science. And flat earthers are...
I'll hate the idea of presupposing a ball. Is
you will get that, sheeple, with your presuppositions, with the apparent locations. If you had the actual locations, you would say, oh my goodness, how on earth did we come up with the ball? When we had the actual location, right?
No. See, that's what you just said. We do know our actual location. I can give you the GPS coordinate down to the decimal point of where I am, and you would find me from anywhere on the planet.
Stars. We don't have the actual location of the stars. So if you had the actual location and size of the planets or whatever in the sky, you would figure out a flat plane.
Chemo, you missed it, man. I don't want to take everyone through this, but it's the angle at which we see the stars that are apparent. We don't need to know, as Curve started with and Kosher carried on. We don't need to know exactly where they are. It's the angle at which we see them that's important. So the angle at which we see them from where we are on the planet for as long as we see them, known as duration, based on observation times, dictates we have to be on a certain size sphere moving.
That's what I'm
based
saying.
Based on all known observations that work simultaneously through day and night. When I've got sun and you've got dark and vice versa.
Right.
All of these things have to work cohesively together perfectly without ever showing a glitch or anything. Everything you present, from a flat Earth, from the seasons to the sunsets to the sunrise to the moons to the eclipses,
Stacey wants to say something.
Interacting with each other, and you need an individual model for each. We have the globe model. You have nothing.
Here.
Can we at least just admit then that you guys all don't know the distances of these places, that you've only seen the apparent locations of everything in the sky, so therefore it's just like the geometric horizon. You've only seen an apparent horizon and apparent locations in the sky. Is that correct?
Fine, but that's irrelevant. No,
that's complete and utter nonsense.
Yeah,
you've just said that.
That's what was said earlier.
You just said that. It's all apparent. The horizon is apparent. The stars are apparent. The angle is apparent. Everything's apparent.
From that, you can't conclude that we just don't know the distance.
No. We're not saying that yet.
We just don't know anything.
No. We're just saying. Are you saying? We're just asking. Are you saying that all these things are apparent? Yeah.
Take their lunch money.
That's like saying if I put a pair of spectacles on, I can't know what words are written on a page because their positions are apparent.
No.
Yes, that's exactly the same thing.
No, it's not.
Yes, it is. The lenses of the spectacles refract light, bend the light slightly to make it appear larger. It's exactly the same thing, and you're saying if you do that, and I can't read anymore now because
you know where those words are. It's in a book right in front of you that you're holding in your hands. You know where that book is.
I'm only looking at it through these refracted spectacles. All the positions of the letters are just apparent. I can't know that they're actually meant to be in words because they're all apparent.
No, they're not. That's actual.
This is. Yeah.
He's using
well, I don't know that looking through my spectacles, do I?
Okay,
but
then there's other people that can verify it next to you that are not looking through those lenses. They can verify where they're at exactly too.
But who does that?
But that's the point. If you're looking through lenses that you can't see clearly, what the words actually say.
So you think all people who wear spectacles always have someone with them to verify that the words are there?
That's not what I said. The point is we can verify things like that. You cannot verify things in space because it's always an apparent location.
Could it be that people with spectacles can know that the positions of the letters are where they are? Could it be that?
You're the one that said that they couldn't. Did you not say that?
No, you're arguing that they can't. You're arguing if it's
this is not a good analogy.
It's all apparent. Yes, you did. You said if because of refraction, the positions of things are apparent, so we just can't know anything about them at all.
But I don't get this analogy
here. What was stated to me today?
I say that's bullshit and silly and ridiculous.
But listen, Jem, how is it? How are the letters
clinging on to your idea? Just trying to find anything so you can say, "Oh well, you can't know that for sure." Well, we know it. We know it to a degree of accuracy that is sufficient for our needs. We can look in the sky and we see recognizable stars that we can recognize from night to night, and they occupy relatively, he said loudly, fixed positions in the sky. And that's all we need.
All right, so let me just look at your analysis.
Like the letters in the book occupy relatively fixed positions on the page.
All right, so look, you've got the glasses on.
He already schooled you. Just give up.
You've got the glasses on. Are you measuring from your eye to the glass or from your eye to the book? That's the problem here, right? So you see the letters on the glass, and you're saying, well, from my eye to the glass, that's the distance I'm going to measure. When in reality, the actual letters are much further back, aren't they? And your measurements are completely off because they're so close.
Just stupid.
You're saying, well, you're saying, well, it's a ball now because
that would be true if we were only relying upon the angular size of the objects to determine their distance, right?
No, but that's what's
we could do that.
This is what's exactly happening. This is what I think Jeremy's point was in the beginning: is that if it's a reflection and you're giving us all this heliocentric model based on the reflection, and we're saying if you actually saw the actual star, you would say, well, actually, it's not a ball, aren't we?
Chemo, why are you pretending that we haven't seen these from high altitude and even higher
That's
than
a different question.
So
that's a different topic. That's a different topic.
How far away?
That's a different topic.
Monologues, guy. At school, we did an experiment where the teacher said, hold your pen up with your arm at a 90-degree angle, about a foot away, and close your left and right eye, and you see apparent movement of about an inch. Now hold it out at arm's length, and you do the same, and you see an apparent movement at about half an inch. The teacher in grade 7, or grade 6 it was, actually said that's how we measure distances to stars, because our eyes are the Earth in relative positions. Now, I don't know, you guys maybe weren't there that day, but that was grade 6 or 7, if I remember rightly, and that was a pen at arm's length. Thank you.
They want to move on, Jeremy. Jeremy, you still here? They want to move on. They've just said
no. We don't want to. We don't want to move on.
No, we're not moving on. I'm just saying that they want to move on, Jeremy, because Cosmos is saying, "Well, we don't need to measure it from the glass, from the eyeglasses to the eye, because we've been there. We've sent probes and satellites beyond
said that.
Okay, so
I didn't say any of that.
Well, I want to bring it back to the actual thing we're talking about.
So what do you mean that we've been there then, Cosmos?
I didn't say we've been there. You're being a disingenuous twat.
So how else do we know other than looking through
I said
the glass?
We have seen these objects from higher altitude with less atmosphere, like an SR-71 Blackbird that flies at 80,000 feet and uses celestial navigation. Now, if
the Blackbird has seen
the
these
amount
stars
of atmosphere, stop interrupting me. If you take the amount of atmosphere that exists at 80,000 feet versus sea level, we have seen as good as we could see the actual location of these objects with as little refraction as possible, and that's with an airplane.
Oh, they've seen the actual stars, Stacy.
Yeah.
So you've seen as good as you can see, and I'm supposed to take that as an actual location.
How much atmosphere exists at 80,000 feet versus sea level?
So you could tell me how it's going to react every single time.
That's a question. How much atmosphere exists in refraction at 80,000 feet versus refraction at sea level? We've seen both. We've witnessed both.
And it flies at, 3,000 miles an hour, navigating via the stars.
Yeah.
But we just don't know where they are.
Exactly. So we don't need refraction. We've seen these from higher up where there's so much less refraction.
Yeah, I don't believe that. Show me that. Matter. Show me that, Cosmos.
Well, that's
you might be seeing a light source in an apparent location all the time.
Oh, yeah,
up, but we still have never verified where the heck these places are.
No, no one's backtracking. No one's backtracking. You've got to verify it first.
No, that's some serious backtracking.
None of this is. I know we went on about this. I told you. I gotta say again. I'm going to show you now the reason why I said what I said and why it's important. I know what Cosmo's saying is exactly right. That the positions are less of a problem whenever you're up in the atmosphere where there's no refraction. But as I said, the question is not where is these objects actually. And the only question is, and this is the absolutely only question, is this object in a single position at all time, at any single time, from every place on Earth? As long as it's in one actual position, then we can all from different places use its apparent position to determine a lot of things about the Earth. I'm going to show you two pictures that you probably have already seen. But
that's what I wanted to hear, Coach, when I asked it. So you're going to tell me too that always locations we're seeing are apparent locations, correct?
No, but that's irrelevant. That's what I'm saying. It doesn't matter.
No, it's not irrelevant. I just want to know, is that correct?
It's going to be an apparent position, sure, but it's not relevant.
Thank you.
Right. What's relevant, what's important is that on Earth, it's in a single position at any single point in time, so that we can use its single position. As I showed these two pictures. One picture is of a flat plane and how that single position from a close range would appear to change as you moved further along a flat line. The other one is how some object very far away would appear from different positions on Earth. And these are the two different ideas that we use in order to make our observations to decide what Earth we're on. One is the bottom one with the globe is equally spaced angles with equally spaced distances. The top one is distances that get further and further away as you move from further from the point that's directly below it. So this is all that we're talking about, and that's, I know we talked about a lot of different things and why it is where we say it is and all sorts of stuff, but that's why it's frustrating, is because it's not important. It's not relevant in this conversation. That's a different conversation. It's an astrological conversation about.
Well, it is important because off the back of your apparent, you're trying to tell us the Earth is a globe, and that doesn't prove the Earth being a globe, Kosho. So it is important. All of your presuppositions, all of your apparentness have got us into this nonsense in the first place, right? If you had actual measurements and stop guessing where these things are, you wouldn't be trying to defend something that can't be proven, right?
See, Kimo, it brings us right back to where I started. Because when we measure those nautical miles, 60 per the degree, all the way down, it comes to 90 of those when you get to the equator. And when you measure the degrees around the equator, there's 360 of them. That would be true on a globe or a sphere. But when you go around the globe, there's 60 nautical miles to the degree as well on the equator. Meaning there's 360 times 60 nautical miles around the equator. Meaning the distance from the pole to the equator is going to be 90 times 60. And the distance around the equator is going to be 360 times 60. And those two numbers makes it a sphere.
Okay, so look, this is not evidence, really.
This is evidence, Kimo. This is literal evidence. And it's not even trigonometry. It's basic geometry.
Jeremy, Stacy, because we were going through, is this evidence? Do they have any evidence? But is this evidence of a globe, Jeremy? Now you've heard it.
If they presuppose how the sky is working, then yes, they have evidence. If the sky's not working like they think, then no, it's not evidence.
Do you remember what my
No, go ahead, Jeremy. Because
go ahead, Jeremy.
He didn't even get to finish his point.
I just told him that, Kimo. I said, "Go ahead, Jeremy." I thought he was finished. Then I said, "Go ahead, Jeremy."
You can say, "Okay, we're just going by the apparent position of it." But that apparent position is going to differ from location to location every time you move on Earth. There's going to be different refraction, different.
That was exactly what my point was, Jeremy. Do you remember my one assumption or one caveat, the one axiom that I was using? The only single axiom I used was that this is at a single position in reality and at any single point in time. We use that single position that it is to go to different positions on Earth where it is going to have a different apparent position. It's going to be lower in the sky. It's angular high. That's what we're measuring. We're measuring how that difference changes.
How is this evidence? You're just saying
it's two different predictions based on what it should do, and
empirical data.
Yeah, you use the data and the observation to see which one matches up.
This is the Mystic Meg.
Matches up to what? To the presupposition of a ball. This is the point.
No, see, you're missing what I point. You glanced over what I said on top of this point about single position. I said time of observation and position of observer plus all known data and observations taken from now until your death have to work simultaneously with everyone else on the planet, and they do when you map it to a globe of our size. You went straight over that and didn't explain, Chemo, how a flat Earth can do the same thing. You didn't even hesitate to run away from that one.
That statement was full of presupposition. You said everyone else has done it. This all matches up with what we already know.
Data,
with the previous
Chemo. It's data.
Yeah, that data.
That's what you need. That's what you need to realize. It's data. It's repeatable, it's testable, and observable. It's scientific, and when we see the constellations or the sun or the moon, that data is now empirical evidence.
Stacey, is this evidence for you that it's the globe?
I don't care what Stacey has to say. I'm telling you what science says.
Aren't we?
I was just wanting my opinion, and I did miss a little bit of it because I was traveling, by the way, back and forth. But from what I had just gathered and heard, for me, it's not enough evidence. No, it's not evidence.
It's data that leads.
Well, we have a lot of data, whatever. We have a lot of that, honey. But at the same time, it's not proof or evidence that for us or anyone.
Right. No.
We need more.
What I said was it has to be work simultaneously with you in the Northern Hemisphere locations, or wherever you are. I won't say Northern Hemisphere, where you are and where I am, and complete opposite to you. It has to work simultaneously throughout day and night, and it has to work glitch-free. And it does when you map it out, and it will work that way from now until your death or my death. It doesn't matter.
Based on what we've been told, right? And math and everything put to what we have seen based on this globe model, built up to that model.
You just said that.
If you guys looked at it completely different and looked at the world differently and not what we've been told, and then did these observations, you might find some gathering data different.
Right.
Listen, we can apply the data that you speak about, but that's not true.
How do you explain the stars then, Stacey? How is your different data explained?
This is what I've always said from the get-go. I don't speak about things that I can't verify or know. I can't verify an apparent location where it's at. I can't verify how this world works based on what I see above that I will never ever visit and see.
You know there are stars, though.
I know there are lights in the sky that react a certain way, do certain things every year.
Just to update you, I mean, I'm sad you've reached adulthood and not got this, but those lights in the sky, we call those stars. Okay, that's the name.
I understand what you call them, Jim. Don't degrade me as a human being.
That's the name in English, the English word that we've given to those lights in the sky. So you could just call them stars because it's only one word and not three.
Right, you could also just call gravity, and because it's a name for something that you have seen, it's the same shit.
What does the Bible say about the stars, Jem?
They are stars. That's the name.
What does the Bible say about the stars? Why don't you look in that?
Oh, the Bible's what? The Bible doesn't just say lights in the sky.
What does it say about the stars?
I don't know. I've no idea.
That's my point. You should research and look up what. If you want to know what the stars are, have a look.
What does it say, Chemo? What are they for?
Does it say? Does it call them stars?
Yeah, but I'm just saying we should look.
What does it say they're for? There's a point here. There's a huge point here.
Oh,
what does it say they're for, Chemo?
Yeah, what does it say they're for? Yeah.
Well, look, we don't want to get into a Bible study.
Yeah, we do. It's exactly what we want to get into.
No, we don't. I'm saying if you want to know what they are...
I want to hear it. I vote we hear it.
Cheapo, you should know what they are as well.
All in favor say aye.
Aye. Chemo brought up the Bible.
No. I was just because Jen was saying that you know what the stars are.
Why did you bring it up if you're not going to go
What are they for, Chemo?
And that's when he ran away.
Conceded.
Now, I would like to tell Stacey why it is consistent, because this is how we navigated the globe before the world. To be polite, not the globe, but just the world. How we navigated it, and we did so with an accuracy of about within a nautical mile, measuring the height of Polaris and measuring when it's midday, and that was all we needed to tell us where we were at. Everywhere within a nautical mile. It means literally you can sail across the Pacific and come into, you know, within line of sight of where you want to go in America or, well, Africa. Either way you say it, right? And that is proof of its accuracy. The fact that it is so. 60 nautical miles to the degree. It's simply that.
Exactly. And it doesn't change what it looks like from any angle that you move away degree by degree. And that would denote that it's not a reflection, and yet the claim of a mirroring sky or reflection, or is not how we say it is, then please provide an alternative, plausible alternative explanation for it.
You see, all of that, you know, reflection nonsense. No, it's just a location that is always in that place. It was what we said. Yeah, reflections and mirrors and shit. What the fuck was that about?
I don't know. But something 90 degrees or almost 90 degrees below at the North Pole would have to be reflecting off something on the ground. So there's a star somewhere on the ground, or there's a, you know, I mean, it's just mental gymnastics trying to work that out.
I mean, you know, when they say presupposition and they, you know, bring in shit like a two-way mirror or whatever, that is a presupposition. That is, you know, just making shit up to explain things. What we did was we said is 90 degrees above the equator, and as we move away, we see this.
Yes, you presupposed it one way. I'm just giving you an idea. I'm just giving you an idea of another way it could work. That's all.
We'd like ideas with evidence.
Yeah, I showed you why it doesn't work.
If you came with as much evidence as we had for at least one thing, you would be credible, and we would take you seriously.
You're saying this is not evidence, though. You're presupposing already. How's that evidence?
As just an idea, your idea is worthless, Jeremy.
Yeah, I can go ask a 3-year-old to rattle off 10 ideas on how grass works. That doesn't mean any of them are right or have evidence.
You don't even understand. You don't even understand what a parent means or how to use it. You think it's some kind of a grand
I would have said
gotcha.
The best globe evidence was the photographs, but even that is not evidence because we can't verify them. So Jeremy's right.
Again, you don't know what evidence means.
Well, evidence supports...
Spurs, to be fair, you can't verify that water doesn't stick to a ball.
Hold on, Chemo. So the black swan is thrown out then because it's a photograph.
Gone.
With no measurements.
I said we can't verify that. We can verify the black swan.
Unverifiable photograph. Useless. Boom.
Verifiable is something that you can
if we took all photographs off the table, we'd still be way ahead of you guys. So,
exactly.
I mean, by far. Like,
wait, there's a bigger difference here. Wait, an observation is done over land, can be redone over and over, and we can do that, you can do that, but we can't go to space. We can't verify those things that we're talking about. So there's a difference in verifying something that can be done on the ground and that I can do, and then you could turn around and do the same thing and get the same result. That's different.
Space.
You mean like looking at the stars? We could do that, right? We could both do that.
Well, you're talking about the black swan picture. That black swan picture can be observed not just by a picture, but actually going out into nature and observing that in reality. You cannot observe things how many light years away. It's verifiable because you're on a ball. We're mainly made up of water. We should have so much curvature over how far. We're on a big ass ball. There should be some kind of proof of this curvature. On our
you want to see it? I'll show you some. You ready? All right. You did the black swan of like 10 miles?
I'm not even talking about black swan. I'm talking about nature shows you that.
Miles.
Forget the picture.
Okay, forget the picture now. It's from a video, just like the black swan.
No, I'm saying it doesn't even matter. You guys are
show me the curvature.
You're not getting my point. Like that. No, that's not what I'm saying. No, I'll look at your picture. That's not what I'm saying.
Guys, you gotta let her finish.
You're literally saying forget the black swan picture because of another photo that we say, hey, a picture is not evidence. I get that. I agree with you. Do not believe that black swan picture just because it's a picture. But reality can show you that picture. You cannot show me in reality what's happening in this vacuum chamber of space that they claim. There's a difference.
And that's what we mean by practical demonstration. So practical would mean show and tell. So you say, look, I'm doing this. This is what's happening now. You explain it as you're showing it. Flat earthers do that. So like you saw with Anthony, he showed you, look, I've got the egg, I've got the salt. The globos never do that. They just explain without the practical demonstration.
I'll explain this picture I just posted. All right,
well, that
3 meter observer height. 3 meter observer height. Still shot from a video. 183.6 kilometers, or about 114 miles. 2,885 meter mountain. With any level of refraction, you're still losing 2,000 meters of mountain due to curvature. There's an entire mountain range missing, including the start of the southern island of New Zealand. Where did it go? Don't tell me it's refraction.
Well, today, that horizon could be behind the mountain, depending on the conditions.
Never, because the water finishes before the mountain range begins. Try again.
I said the horizon. I didn't say the water. So we got the horizon. Remember, the horizon is not physical. So because it's not physical, water in this. Yeah, but again,
that's water, Chemo. That's water.
I know.
Creating the horizon. Water.
But I'm saying the horizon can move behind that mountain on another day.
It can't. Chemo.
We have evidence and we have proof of such a thing.
But the horizon created in this picture is water.
I'm not saying what it is. I'm saying the horizon can move in front of that object or behind it.
So the ocean's going to move into a mountain
I don't know
range.
about the ocean, but I'm saying the horizon, because it's not physical, can be behind that mountain or in front. Anytime, depends on the weather.
I'm afraid not.
We have proof and evidence with the Black Swan.
I'm afraid not, Chemo, because that's 183 kilometers to that mountain summit.
Doesn't matter the distance. The horizon's not physical.
It doesn't matter the distance. Okay.
Well,
there's always going to be water.
Physical. So if that's
there's always going to be water, Chemo. That's what you've got to get into your head.
If that's
that horizon you see there is water. It's never going to be land, and that water's never going to leave the water and go behind the mountain.
I'm not saying the water will go. I'm saying the horizon will go behind that mountain on any given day.
Why?
No, it won't.
Because why curve? Because the horizon is not physical.
The water is physical.
It may well be physical. Water may be physical, but this horizon, the horizon, can be behind that mountain,
what picture are you talking
in front
about,
of the
Kima?
Mountain, anything it wants to do because of the Black Swan.
What
we have
picture are you talking about, Kima?
Sorry?
What picture are you talking about with the mountain and the horizon?
The sheeple's got a mountain on I'm looking at here. Put it on my screen. But he's saying explain that picture, and it's
7 minutes after the hour.
Yes, that's correct, Curved.
Okay, now how would you get the horizon if you're down anywhere near the water level? How do you get that horizon to go behind that mountain, that water horizon, to go behind that mountain when that mountain is that far away? When have we ever seen this, Kima?
When have we ever seen this?
Yeah, in the scenario I just laid out, like similar to what we're looking at here in this photograph. When does that horizon go behind that mountain, Chemo? Do you eat with this mouth?
With this mountain, yeah. So you just have to wait a day.
With their mouth. The mouth that this shit is coming out of. Do you eat with that mouth, Chemo? It's very unsanitary.
But yeah, I mean, it's a very simple understanding. Because of the Black Swan, we understand that this
you
horizon...
should say that again. That's an extremely simple understanding. So simple, it's not even understood. It's bullshit.
Again, it's painful, right? But that's what the whole argument of the Black Swan has been about all this whole time, is that the horizon is not physical, so any geometric horizon that you try to show us is not going to be physical. You have been telling us this for the longest time. It's not physical. So why is he showing me a mountain with a physical horizon that's not physical? Like this
when does the horizon move behind the mountain, Kimo?
Yeah, we've got a great example. So we've got the horizon in front of the platforms, And then on another day...
No, the mountain, Chemo. The mountain.
Doesn't matter what it is. It could be anything.
The mountain.
It can be anything.
Chemo, the mountain.
It can be any object. Any object.
Okay, so you want to run away from that claim.
No, he's saying it could be
That's
anything,
fine.
a mountain or any
that.
object. I
You
heard
can
it loud and
concede that
clear.
You just spewed out a bunch of shit, and you got nothing to back up that claim with. That's fine.
Oh, we've got the Black Swan to back it up. We've even got Dr. John D with his observation of the Black Swan. This is the very argument that you've been missing the whole point. I don't know how long now. Remember, the horizon's not physical. We've been waiting for the day, actually, for sheeple to do something like this and say, hey, look, where's the bottom of the building, bottom of the mountain? We're waiting for that because we've had to explain it's not physical.
It's checkmate, Chemo. It's checkmate. You can't bring your closer observation where water is behind and in front and try to use that as an argument against my version, because my version is not the same as this, so it's a false equivalence.
Bear in mind,
so you need to provide where those things or buildings are up on land, and then somehow water leaves the ocean and goes behind them. That's what you need to provide. Otherwise, you lose.
I've got it on the
Nobody's making water go behind anything. I also heard him state that too. And Horizon's not a fixed place, an area of Narnia that you can visit. Okay? We're talking about
Stacey,
what?
But maybe you missed.
Position of light you say is bending and causing it to refract, and that's why we're seeing the horizon. That's what Jim and everybody has said. We're not seeing the geometric one, we're seeing the apparent one. So therefore, what?
You missed it. And I'm
what
going
did
to
I miss? I heard him loud and clear. You guys kept stating where is it going to be, behind the mountain or front of the mountain? When can it be? And he said
the ocean that divides the two islands of the North and South Island of New Zealand will never be in the mountain range 183 kilometers from the observer. Ever. Chemo's claim was the horizon will change. I told you that the horizon in that image was created by the physical ocean. Your turn.
It's still the apparent horizon. It doesn't matter.
Correct.
Yes, and the apparent horizon is a place that I can send one of you to.
You cannot send me to Narnia. Please send me to Narnia, but you cannot send me to Narnia.
This, you know,
Once I get to that position, that horizon has changed again. Every time I move, that horizon is moving with me.
Exactly.
Just let me say this, and then we can see what happens. If I'm at the shore and you're at the shore, yes, every time you move, but if I'm at the shore and you're at the shore, and I go on my little boat, and I call you up on my phone, and I sail out, and I tell you, tell me when I'm at your horizon, then I am physically there at some point, right?
But how do you know where it's at? You're only seeing an apparent location. How can you verify where that distance is? Because you don't know where it's at.
No, you verify.
Stacey,
it's your horizon.
Every time I move, that location moves with me. So where is it?
Well, don't move.
What I said was, I sailed to your horizon. You're telling me on the phone when I'm at your horizon, right?
Wait, she
I am
just said
going
something.
to your horizon. In the example, right?
The horizon is not a place that you can go to.
Your horizon.
It is where you're seeing the ground meet the sky. You're seeing an apparent place. It is not a real place.
Stacey,
what would happen if you went to where that apparent location is?
Okay, we're gonna guess where that apparent location is. We're gonna guess where it is because it's an apparent location.
Would you fly off into a black hole? What would happen if you went to this apparent location?
Exist. Come on, show me proof.
What's so unreal about it? What's so unreal about it?
You can't measure it. You can't
use
use
not
geometry.
a real place that I can visit. It is a place that I have seen. That is an apparent place that I think is there, right? Where it looks like it is. But once I get to the actual place, I realize it's not there.
At your apparent horizon.
So if you saw a boat on that horizon, those people on that boat, they're not there.
Oh, here's the difference. If that boat doesn't move and I travel to that boat, I'll end up meeting up with that boat. But if I keep traveling to the horizon, I never meet that horizon.
But what if you don't? What if you're standing on the shore?
Are we kidding me? There's a boat on the ocean. I travel towards it. I come to it.
Can I finish?
Stacy.
No. Let me finish. For fuck's sake. You don't travel to it. You see a boat on the horizon. Is there a boat on the horizon?
Yeah, we see a boat on the horizon, and we're just gonna wait.
There's a boat,
and then we're just gonna wait. I wasn't done, guys. We're gonna see the boat on the horizon. And we're just gonna wait.
I wasn't asking you.
Why?
Because you shouldn't even have started.
Right. But is there a boat on the horizon? Does it actually exist?
There's a boat that looks like it's on the horizon. Looks like it's not actually on the horizon. It's on the ocean, right? In the ocean?
Right. So the boat actually exists at a position somewhere on Earth, right?
On Earth, right? Because it's an actual object. It's a real thing.
Not in Narnia, on Earth.
Right. Because it's real.
Right.
An object. A physical thing.
Right. A real physical thing. Right.
Can I interject for a second? Or
I agree.
No?
Is the apparent horizon a physical thing?
So you tell me. If the boat is a real physical thing, you've just agreed that the boat is a real physical thing. Let's just clarify.
But the apparent horizon is not a physical thing.
What about the water lapping up on the side of the boat? Is that a real physical thing?
It's a real thing. I can feel it. I can see it. I can observe it.
There you go. Well, you've
answered. But I cannot feel the horizon. I cannot touch the horizon. I cannot be with the horizon.
The boat is on the horizon. The boat is a real thing. The water lapping up against the boat is a real thing, according to you. And the water lapping up against the boat is the horizon.
But the boat being on the horizon is not a real thing. The boat looks and appears as it's on the horizon, by the horizon. It's not actually on the horizon.
Stacy, we could just wait. We could just wait, and then the boat will change. Never mind.
Go ahead.
We could just wait. We're a viewer. We're looking at the boat. It's at the horizon. We're just gonna wait an hour, a day, a week. Eventually, the horizon's gonna change, and it's not gonna be on the horizon anymore.
The thing is, guys, the boat's never on the horizon because the horizon is not a fixed place. It is where the sky meets the ground. So no matter what, it's just your eyes, okay? It's perception. In reality, nothing is ever touching.
We've just agreed that that's not true. But we've just agreed that the water, which makes
I never agreed that the horizon is a physical place. It is what you are seeing because from far away, Sorry, this kid's talking. Let me go to another room, honey.
So the boat is only at an apparent location, Jim. It's not in a real location.
Apparently, yeah.
You guys have no response for what I said.
The boat's in a real place.
Right, but you say the real place it's in is not a real place and it's just apparent and is Narnia.
That's absolutely BS. We have water on Earth and we can swim in it, touch it, observe it, be real. We could be on a boat, it's real. The horizon itself is not a real place, Jim. Now on your ball for a geometric horizon, but where is the boat? Okay, you know what? Here we go. You're right. Let's get a real spot. Let's go to the geometric horizon, Jim. Let's all travel there because it's a fixed place, right? An actual real place to go to.
Ooh.
Let's all go there, Jim. Let's meet up at this geometric horizon that you claim exists.
Wow. Yeah, well, we can do that, can't we? You're telling us that there's a boat on the horizon and the boat actually exists.
But you said that's an apparent location. That's a refraction causing that actual location. So let's go to the geometric one that actually really exists. And let's all stand on that, please.
Oh, how do you know that? I say it is the geometric horizon. You just see it in an apparent position.
There. Okay, right. But that one that you're seeing is an apparent, right? It's not real. It's not exactly where it's at. It is real. It's not where it's at.
You're standing on a geometric location.
Geometric physical, right?
It's a slightly different
place. For you. This is for you. There's a geometric
physical. How does that change anything? How does that change
There's an apparent location where it's been refracted, you said. So we're seeing the apparent location of refraction of the geometric one. This is what you guys claim, or who you claim, whatever.
Yep.
It's okay.
While standing on a geometric location. Well done.
You're standing on your geometric ball, not the geometric horizon. Let's make that very clear.
We've agreed. But we've agreed already that at this apparent location that nobody can ever go to, there are already people on a boat there, physically there. But nobody can go there because it's Narnia, but there are people there.
No. Because if you're on that, wait. If you're on that boat, is that horizon in the same spot? Incorrect. They're not on the horizon.
To you, yes, it's your horizon.
People on the boat isn't either. People on the boat are going to see a horizon in a different spot than where I'm seeing it.
Do the people on the boat?
So where is that geometric horizon? Are they standing on it? Are they on it?
Do the people on the boat exist physically?
Oh my God, we're going to turn to, are people real?
Well, you're saying they're not. You're saying they're Narnia. That it's Narnia.
No. Your location is Narnia.
Listen, you're saying the place where they physically are, the actual place on Earth where they are, is Narnia. That's what you're saying.
No. Yes. I say, no, wait, stop. There is a longitude and latitude and a spot on the Earth that they're at. However, that horizon is not a real
from your point of view, and from your point of view, that is on the horizon. But you say, if it's the horizon, it's Narnia.
It is a point of view. It's not a real object, a real place.
So the physical boat that you just agreed is a real physical thing with real people on it has just now become not a real thing.
That's incorrect. The boat is real
is it
on
a real
the ocean.
Thing?
The horizon is not. Oh, for the love of God!
Is it a real thing?
Are we second grade?
Is it a real thing? And is it in a real place?
On Earth. It's not in the horizon or at the horizon, Jim.
From your point of view, it is.
Because it's the point of view and it's what it looks like. It appears. Exactly. It appears apparent. Apparent. Do you not understand?
Yes, I understand. You're saying.
Where does your geometric horizon?
You're saying. Can we go to it, please? You're saying that if we insert the word apparent, that suddenly the physical boat with the physical people on it suddenly stops existing in reality and becomes Narnia. That's what that's an idiotic, ridiculous argument you're trying to make. Well,
if it was a geometric horizon and you met there and it was an actual physical place, right? Then it'd be okay. But we're not meeting at a physical place. We're meeting at the Earth. Not the horizon.
The people on the boat are meeting at a physical place.
No, they're not. They're meeting on the ocean. They're not meeting at the horizon because the people on the boat see the horizon at a different place. Jim, the people on that boat do not see the horizon where they're at.
No, you see it. You see them from where you are on the horizon.
So they're never at the horizon,
which,
Jim.
according to you, suddenly makes them Narnia and makes them not real anymore. That's your ludicrous, idiotic argument that you're trying to make. It's absurd.
Can I do an analogy real quick?
Go for it.
Let's say we got somebody looking at somebody at the horizon, and then someone's looking at someone standing on top of the Great Pyramid, right? Now, the person looking at the people at the horizon, they can just wait, and eventually they're not going to be on the horizon anymore because the horizon moves. But the person looking at the person on top of the pyramid, that person's always going to be on top of the pyramid. He's not going to change. He's not going to never not be on the pyramid.
Yes.
And if we were to take a GPS location for each of them, they would both be in the same place.
But not the horizon.
But not the horizon. Thank you.
So what? What difference does that make? Why does that change anything about
Because then they're not at the horizon. It looks as if they're at a horizon, but they're not actually there.
So what? So what? What do you conclude from that?
Set up a scope with the reticle centered on that person standing on top of the horizon. It's on a tripod. The scope does not move. That does not mean that that person will not move out of the center of that scope through time as well, with varying conditions due to the same thing. Refraction, Jeremy. It's real. Learn it. Understand it.
No. Nobody's saying about damn refraction, not refraction. We're literally trying to state that you're seeing refracted from what Jim says and actual refracted horizon. Therefore, it's not a physical place.
It's important to note that the horizon is defined as an apparent position, meaning that it's It's not
No,
describing.
it's not.
It's not
No,
describing
it's not. No, it's not.
the horizon.
Absolutely
Drop
is.
that apparent at the beginning of the definition.
Why don't you look up the meaning of horizon and you tell me what it says? Thank you.
You're wrong, Curve.
Can I have just a
the line where the sky or Earth appears to meet the sky. The line where the Earth appears to meet the sky. Not the apparent anything. The line where the Earth appears to meet the sky.
Keep looking.
I'm being fussy about this for a fucking reason.
Yes,
Yeah,
we know
can
this.
I add to that? No,
Yeah,
my turn. Definitely my turn. Because, you know, I'm looking at the corner of my house.
Where I was going, okay.
Oh, Joe, just a minute.
Come on,
I'm looking at the corner of my house. And a couple of meters, no, shut up. A couple of meters behind that corner is my hedge that I haven't cut for a while, but that doesn't matter. That corner of my house is the line where my house appears to meet the hedge. I do know, though, that I can go between those two. It's still going to be that, you know, apparent where the corner of the house meets the hedge. That's the corner of my house. Both things are real, though, right? So this nonsense saying that, you know, where the sky appears to meet the water or the surface. Well, yeah, it's not going to be, the sky is not going to be in the location of that surface. The last surface that you see is going to be something behind it. Same as my hedge is behind the house. Right? Got it?
Thank you, Stuart. I'm going to just leave before I pick up where I left off. That's all right. Yeah, Curve, that's fine. Where the sky appears to meet the ground, I'll still use... I can use that for what I was going to say anyhow. What that's describing, where the sky appears to meet the ground, is not going to be the same... you're going to be able to mark that position, you know, at any given point in time. But that position is also going to change because of refraction, because it's only describing where the sky is appearing to meet the ground. So that's why when you say like a pyramid and someone's at a pyramid, the pyramid's always going to be where the pyramid is. You can mark the position where the sky appears to meet the ground now or later, but that position could change. So that comparison is not necessarily a fair comparison.
So that mountain that he's showing people is not evidence, because that horizon will never be in the same place for a minute. Not even a minute. It'll never be there. It will
so let's use Jeremy's example before you try and sneak that in there, or about the person standing on the pyramid will always be on top of the pyramid. Well, here's the thing for you. That mountain peak will always be the mountain peak. And there's no known force I know that can move a mountain. So that water horizon, or that physical water, will never ever be behind that mountain. And I'm putting together a quick little slideshow for those with short attention spans, and it's going to show you exactly what you're dealing with. So you can see just how much mountain range is missing before that mountain range is cut off. Now, you still haven't got away from asking where the 2,000 meters of that mountain have gone. Thank you.
Nice.
I'll be back momentarily. It's for breakfast. It's don't want to be doing this around a bunch of kids. I will be back.
Taking that pyramid.
100% real quick what Wolfgang said. Yes, if I traveled to that exact tree where it was at the horizon, the apparent supposed horizon that I was seeing, when I get there, yeah, that tree's probably still there. Of course it is. But in reality, that horizon has moved. So my point is I can never actually get to the horizon because it's always moving.
That horizon didn't move anywhere. You're seeing a different part of the Earth as your horizon.
Right.
There is a
No,
difference.
but that's my point. I understand that, but the horizon's always going to move with me.
According to the geometry of the sphere. What's the geometry for the horizon of a flat Earth?
Geometry? Shape?
Distance. Angle.
Because I can't tell you how big this Earth is and what's going on in this Earth if I can't measure it all.
You've got nothing you can work with. You don't even have an explanation for why you have a horizon.
But the point is they don't have an explanation. All they've did is a bunch of math and a model and concepts to fit it. In reality, it doesn't work. Besides what? To math? You've never been to this geometric horizon, but we claim it exists.
Models
I've never seen it in video, but we claim it exists. But where is it?
As if that's a mark against
How did they ever know there was a geometric horizon if no one's ever seen it?
You don't never bother to wait till I'm done either.
Well, you've been rude the whole morning, even when people were being nice, especially to me. Kurt.
Rude to you.
Yeah, you overtalk people.
Not coddling
Same way.
you is rude.
You never let anybody have their opinion as well.
You can have your opinion, and I can tell you that it's wrong and invalid.
Right, and so can I, correct? You don't have to be disrespectful and
but
say little
only
things
one of
in the
us will be
chat.
correct in the matter.
Right? Oh, really?
That's the part
and
you don't
claim
understand.
It's you.
Just because you have an opinion does not mean you are correct.
Absolutely, same to you.
But we can demonstrate the veracity of our claims.
Can you please demonstrate the geometric horizon, please? Can you show me the geometric horizon? Thank you.
What quantum?
Can I see any video of the geometric horizon? Not the apparent one. Where's the geometric one that you say exists? Because you've had to see it to know it exists.
What's the geometric horizon, Stacy?
The geometric horizon is where things are obstructed and you can take
chemo, Stacy, now.
No, because you know what? You guys do this all the time. How many times have I been over here and you talked about the geometric horizon? You're the one that claims we have one. Where is it? You tell me what a fucking geometric horizon is.
What do we say it is?
Ever be seen ever on Earth.
If you don't know what it is, what are you arguing against?
Where the sky meets the ground because you're on a fucking ball.
If you don't know what the geometric horizon is, why are you even using it in your argument?
Who said I didn't? I'm asking you to show it to me.
No. I'm asking you to tell me what we say it is.
Did I not just freaking tell you?
No, you have not told me what it is.
Well, wow. And maybe you need to open up your ears and clean them out this morning.
Why don't you say it again then and be clear? What is the geometric horizon, as we call it? It's a very simple answer. You know it or you don't.
Geometric is the physical horizon curve that obstructs boats, buildings, the sun. When you ask us to explain the sun, what does it go behind? It's not going behind something physical.
That is not at all how it's defined.
You need it to be physical.
Lovely example of my house and the corner of it and the hedge behind that. The physical horizon would be that corner, right? If I threw a ball at it, you know, if I hit that exact corner, that would be the physical horizon, right?
No. The physical horizon is where the Earth starts to drop away beyond that point. What we're showing you is that beyond that point, where Sheeple shows that mountain, the Earth doesn't drop away. You can't measure it geometrically. The rate that it should fall away, it keeps changing. See?
That's called refraction, Chemo. But the physical horizon in my example of that house meeting that hedge, right? that physical horizon would be that physical corner of my freaking house, right? If I threw a ball at it and I just barely missed the house, I would go over the horizon. If I threw a ball and just hit that corner, I would hit the horizon, right? That would be the physical horizon in my example, right?
No. Where you're 6 foot, the physical horizon should be around 3 miles. That means...
Using my example of the corner of my freaking house with the horizon on the water. Stop that.
But hold on. What it means is that beyond 3 miles, I cannot see around that corner.
Right.
Yes, and we got refraction covering that.
Unless
I'm asking you if you agree. No, I'm asking you agree on the definition that I'm applying, and I'm using the example of the corner of my freaking house. Would you agree that that physical freaking corner is my horizon in that example?
Look, stop red herring. Red herring.
It's a visual example that we can all relate to.
This is a red herring, this is.
Right? No, Chemo. It's a simple example. I'm asking you if that physical corner would be my horizon in that example.
No.
What would be my physical horizon then? Obviously the hedge is blocking, further vision, so what would it be?
No. So your physical horizon depended on size of the Earth. So if the Earth is 3959...
When I'm simplifying it to looking at my freaking house in my garden...
No, that's not the horizon, no.
It is the same thing. It would have to be
Alright, what's the radius of your house then?
My house is apparently not curved, it's
so
flat.
What's the radius? Then I can tell you that horizon should be no more than what? Work it out.
It's going to be about 8 meters away from me from where I'm standing now, isn't it? It's not a big house and I'm in the middle of it.
Let's say your house is 3959. Yeah? So your physical horizon on the corner of your wall...
But still,
the corner of your wall...
If we look at it in the same way, your
physical head should be 1.22
explain the concept of the physical horizon.
Feet in height.
That corner of my house, and then there's some grass, and then there's the hedge. Where that hedge...
Yeah, but to know if it's the physical horizon, I need the radius. You just asked me where the horizon is. Where's the horizon? What's the radius of your house so I can work it out?
That corner of my house...
You're breaking up, or is it me?
...is my horizon.
Is he breaking up or am I breaking up?
In that, understanding, right? Is it or isn't it?
Breaking up, Chemo.
I'm breaking up.
I was me and you.
When we were together. But look, I mean, if you could tell me the size of your house, the area, then I can tell you if that is physical or not. But just to say physical horizon out of the blue, it doesn't make any sense, right? What we're working out is if the Earth is this big, then the physical horizon should be no more than, the allotted size, right? If P then Q, you know all of that, right? Modus tollens and all of that, yes? How can you just say, where's the horizon, where's the horizon?
Can you be more clear on that, Kimo? Can you actually say what you were saying?
Well, Nathan's still on. You've got 20 minutes if you want to go and clear up the old modus tollens. That's pretty much his argument. I get it, I understand it. It makes good sense. But,
I'm just kidding. We know he can't remember what it is.
For me,
I'm here afterwards. Talk to him.
For me, your picture sheeple just shows that the horizon can be behind that mountain or in front of that mountain.
But they can't.
That's what they said about the Black Swan.
The Black Swan is not what we're looking at here, Kimo.
Every horizon is the Black Swan.
Yeah, so what?
That means the horizon is not physical.
But how's the ocean going to get behind the
ocean won't
area where there's no water?
The ocean won't get behind it. What will happen is once that horizon's behind the mountain, you'll see the bottom of the mountain.
And that's what you're sticking with. All right, then.
I don't think that Kimo also said that spheres only have horizons. I don't know who just said that in the chat, but I don't believe that Kimo is stating that.
No, I didn't say any spheres as horizons. I said if he wants me to figure out, if he wants me to figure out the horizon, then he should give me the radius, the size of the object, so we can figure out how far from my observer. On the observer, I want to figure out where it is. I can know that if I have the radius, right?
I told you. It's even in the description.
Yep.
But you guys got the radius based on a geometric horizon that was never seen, so isn't it being done backwards?
Not when you know the height of the mountain and you see what mount's hidden, and the curve calculator works even with refraction included to the roundabout to the meter accuracy of how much mountain you can see. No, it now becomes a formula or a method with predictive capabilities that are empirical and testable and get results and cannot be falsified. Doesn't matter about its origin. The fact that it works and its predictions work.
Well, you can always make math work around a model. You can definitely put up a model, create something, make it work
or a flat Earth.
Right?
No, but you only have
if we actually had enough people trying to care about this message and actually really out there and observe, we could probably get somewhere with a concept or a model. I don't want a concept or a model, though. I want reality.
All right, I'll tell you how it is. If you had anyone actually scientific on your side, you might have a shit show in hell.
No, that's what we're into now, huh? But that's okay. 66,000 miles per hour, 66 this, and all these fucking numbers and maths that make no sense in reality. Just so it's a concept and model, but we'll take it on board.
Big numbers are scary sometimes. I agree.
I know, right?
Big numbers, it's always the same numbers, right? 33s, 9s, 3s, and 6s, and this bullshit is 666. And you guys don't even question that? All their symbolism in the space videos, and you don't question that? I mean, come on, wake up. They're giving you numbers and math based on a model that you can never prove in reality. You're basing a geometric horizon you've never even seen. No one has. No one.
Oh my goodness. Yeah, I don't even think you know what a geometric horizon is either.
I've already went over it, and if you don't fucking understand what a geometric horizon, and we're here talking about a ball at this point, we've talked about a lot of things. If you don't understand that at this point, then you need to Google.
You want to try again?
I can Google, you can Google, we all can Google, right?
Go ahead, Google it, and then maybe you'll give the correct answer.
Geometric, G-E-O. Let me spell it for you, honey. Metric, M-E-T-R-I-C. Horizon, Google.
There's no fucking need for that. You're the one being
Well, weren't you really rude to me, demanding me to tell you geometric horizon, which I didn't? You didn't like the answer, then you still were rude and fucking put me down?
Your inferior position. Do you understand that?
Because when somebody doesn't agree with you, you're rude.
You understanding what geometric horizon means.
I don't think you guys understand what your geometric horizon is, and you're on a ball of a geometric shape.
Well,
we definitely know what it is.
Do you need that, sweetums?
Sweetie pie, sweetheart, honey bun.
Give the definition. Do you know it? You keep using it. You don't seem to know it.
How many times have we all heard it? Chemo just gave it. I was giving you a definition of it. You guys even gave it. I'm listening. Stop your fucking 2-year-old shit.
I never gave it.
I also never gave it, and Chemo didn't give it.
So you're going to tell me that nobody gave the fucking geometric horizon in here? You are full of shit. Rewind.
I did not tell you what the geometric horizon was. This proves you do not know what it is.
For fuck's sake. This is why nobody comes over here and wants to debate correctly, because you guys want to literally derail on some bull-ass shit because you can't stick to freaking facts. And then you want to call people cunts and assholes and everything else because you can't stick to facts because you don't have any to prove your globe.
The fact is, Chemo didn't say shit about the geometric horizon.
How long would it take you to look it up, Stacy?
Do you realize that I could have already Googled that for you and posted it how many times, but I don't feel the need to Google that for you because you're a grown damn man? But you want to disrespect me as a 37-year-old woman because you're an asshole. I'm sick of the rude-ass ways that you guys want to act on this server. I can just go ahead and disappear, and that's fine. I could really care less. But you guys do not know how to have a discussion without putting somebody down, and it's rude.
No,
Are you a man?
Speak to Stacy, please. Only cuddlers from here on out.
Let's go learn to be a man and have a discussion instead of being rude to people.
Why don't you learn to be a woman?
At least I try to be one and act like one, and I don't try to be something that I'm fucking not.
You know, maybe if you did try a little harder, people would be different with you.
You know what, sure, it's funny. That's why you guys, and Amy Gems even said he misses and wants that relationship that we all have over there on the other server, right? Because in reality, we respect one another. You guys don't even respect one another between yourselves.
You run people off your server who don't agree. Don't act like you're perfect. Come now.
I never said the heck I was perfect, but apparently you guys are.
No, we're not perfect, but I tell you, we definitely call each other on our bullshit. No one lets shit slide.
We don't call each other on bullshit. Think again.
You got a bunch of
You don't know shit about that server.
You know, they hasn't even told you what a geometric horizon is yet.
A geometrical horizon bullshit is not it, Kima.
It's ridiculous.
That's that
Simple
National Geographic article thing, and that's not what we're talking about.
Simple observation of a mountain, and you guys have no answers for it. So you run back to QE's rhetoric monologue bullshit that doesn't apply here.
I didn't mention QE, and I haven't mentioned QE once or anything about the black swan or nothing.
P
You all
versus
just fucking
P
name
and
drop.
Q, all this crap. You don't think that's QE? Is that what you're telling me?
Did I ever state that? Did I ever see any of those fucking things?
Instead of answering what a geometric horizon is? Come on now. Be
Because we've
honest.
been to this geometric horizon how many times? I've even been over here and explained it before. You guys do this every fucking time.
Okay, well, the geometric horizon argument, Modus Tollens, is not going to save you in this one. This mountain is a real problem for Flat Earth.
I really don't care about your mountain. The problem is you guys don't have a fucking geometric horizon, and you guys claim you do. Then you would have claimed this as a parent horizon. It's only supposed to be, what, so far away, and it's too damn far away.
Okay, let's move away from the horizon. What's hiding 2,000 meters of mountain?
Oh, wait, why move away from the horizon? Because even on space.com it says how you debate a flat earther is you talk about the horizon.
You don't want to talk about the horizon and what a geometric horizon is, so let's just answer the basic question, which you've been running from. Jeremy went silent, Chemo ran, you don't have an answer. What hides 2,000 meters of that mountain on a flat Earth? 2,000 meters! It's not like a brick wall.
It's not a physical. It's not a physical obstruction. It's just an apparent.
It's a physical mountain, Chemo.
No, but the obstruction is not.
Yeah, you're gonna see in a minute how bad this is for you. I'm just making it look pretty now. I'll be with you shortly.
Everything about that obstruction is physical.
No, the black swan shows that the horizon can go in front of the object and behind the object.
That was a nice non sequitur. Everything about that obstruction is physical.
Get away from the black swan, Kuma. You went to Sheeple's Mountain before. It's coming back to you. Explain Sheeple's Mountain. Is your Waterloo, buddy.
Easy to explain. Like I say, if he was to go there on another day, he would find that horizon would have moved its position.
You're toast, Chemo.
That doesn't answer the question, Chemo.
How is he toast?
Because the Phoenix is toasting him.
Chemo, the fact that it moves just proves refraction now. That's all.
I mean, whatever you want to call it, yeah. I mean, you can call it whatever you like, really. It doesn't really matter, really.
But what are you going to call it, Chemo? Are you going to call it Earth feels like having a different shape on a day, or what?
You can call it whatever you like, but we know that that obstruction is not physical, and on another day, it will move.
Chemo.
It's horizon fluid.
But it's displayed visually different every day.
I know this is freaking you out, probably blowing your mind and all these things, but this is
it's horizon fluid, isn't it, Chemo? That's what it.
This has been the black swan argument for the longest time, which is why a lot of
You've been not even the black swan argument for a long time, Chemo. That's all. Refraction is physical. The Earth is physical. Everything about that horizon is physical.
I know, but that obstruction will not be there on another day.
Is water physical, Chemo?
Well, you can shoot a cannon at it and see if it's physical, can't you?
Oh, if you shoot a cannon, straight at that horizon or just below it, it will go straight through it and hit the bottom of that mountain.
No, it won't.
It's not physical. This is what's freaking a lot of you guys out. I think they're getting it now, Stacey, Jeremy. They're just dawning on them, right?
It's incredible.
Come on, let us go with this cannon example because this is going to be good. You see, if we shoot that cannon and we assume we have a cannon that shoots absolutely straight, and we set it up the first day, wherever the freaking horizon is on that day, and we let it stand there shooting that same line every day, it's going to hit at the same distance out in that water every freaking day.
Well, let's say we could make it. Let's say we had. Let's say we could fire the cannon. Let's say we could fire the cannon strong enough or with enough force to hit the bottom of that mountain. Yeah.
Emo, you can answer when I'm done. Every single day, it's gonna hit that same spot of water in that same distance. Every day, it's never ever gonna move, no matter how it looks. Horizon above us, horizon below us, doesn't matter. It's gonna hit that same spot of water every fucking day. And when we adjust it to go a little higher so it doesn't hit that water, so the next water, yes, it's gonna go further. And sometimes it's gonna hit behind our visual horizon, but it's still gonna hit water, and it's still gonna hit water in the same location till we change the elevation of the gun. Every day, same location. Meaning, what you see is not in the physical location where it can be physically touched. It is moved. It is optically moved. Right.
Chemo's just saying that there's a chord. You can describe a chord between 2 points on the sphere. And he's pretending he's got a cannon that would not be deflected by the water, so it would follow the line of a chord from point A to point B. Point A being you, the observer, and point B being the foot of the mountain.
Let's just be honest here, though, that you guys only measure that geometric horizon based on mass on a globe, right? And a sphere and a radius. You actually have never seen it. You're just basing it on the 1.22, right? 1.225?
We went over
But in reality,
No,
you've never,
Stacey,
ever
no.
seen it or measured it.
No, we're not doing that.
Of course you are. That's the radius. How are you not basing it on that?
That's how you're getting the radius based on that.
it.
We do not use the distance of the horizon.
You did not follow my whole navigation thing and how sextants work. Not my problem.
We do not use the distance to the horizon to calculate the radius of the Earth.
It was definitely measurable, and I
Cracking up there.
told you how.
How do you get your geometric horizon then? Please explain, thank you, and how you measuring 1.22, and how did you know it was 1.225?
From 1 foot, how do you know it was 1.225? How do you work that out?
Yes, thank you. How do you figure that out? How did you know those mass and that was going to be that way? Please explain.
Be clear. Let's be clear about something then, because it depends on what you were just stating and what they were saying no to. Because what they were saying no to, I think, was referring to the radius. Is that right? People who were saying no.
Well, why don't you let them answer, Coach?
Right, but they weren't saying no to. I think what you say. I'm not sure exactly what you said. You said 1.225.
Right. That's how you guys are seeing the geometric horizon based on mass. But how are you getting those mass? Where are you seeing? Because you've never seen this geometric horizon at 1.22. So if you're not seeing it at 1.22, how did you know it's at 11.22? Please.
Because we get
Could
the
we know the radius of the Earth?
Can you guys not hear Slacker? Slacker's
trying
trying
to
to... Go ahead, Slacker.
that have nothing to do with the horizon. And then we can do the geometry to calculate how far a geometric horizon would be.
Huh? Say that again, Slacker. You've presupposed something in this line of thought.
That's not what I said.
I can barely hear you.
We get the shape of the Earth through various other methods that all corroborate each other that may or may not have anything to do with the horizon. Most of them have nothing to do with the horizon at all.
Mm-hmm.
Then we do the geometry to calculate the distance to the horizon.
Okay, but those other methods have presupposed the ball also, Slacker.
Except they haven't, and you're just going to keep denying that.
No, I'm asking you,
They
which
work
method
together,
hasn't
Spurs. They all work together.
I'm asking you, which method hasn't presupposed the ball?
Looking at the elevation of Polaris, looking at the elevation of the sun.
Yeah, again, presupposing the ball, Slacker.
Except that that's where you're wrong. You can keep denying it, but That's not true.
No, it's based on presupposed dimensions, and those presupposed dimensions came from prior history, which then was done by a geometric horizon, which was never seen, but mass was put to a ball, and that's what you got.
No, that's not right.
That's not right. So who measured?
Okay, why is it not right?
Who measured the Earth then, Bazar? If it's not right,
Aristarchus.
How did he do that?
Yeah.
He worked out the distance between two places on the planet and weighted of a known distance apart and worked out what fraction of 360 degrees, because 360 degrees is the number of degrees in a complete circle. And the
yeah, but that was two presupposed locations on a presupposed ball.
Talking, Chemo. He was still talking.
Yeah, but Aristarchus had to presuppose.
No, you just do
have to interrupt.
Finish.
Fucking hell.
Observations do not have carry no presuppositions. You are measuring an angle between two physical locations on the planet. You know the distance between them. None of this stuff presupposes any shape. It is a pure measurement, an observation. It's just an observation of what is observed and information gathered from that. There is no presuppositions in measuring or observing things.
Go on then. So how did him and the other guy communicate with each other to get their angles?
Especially back then. Let's be really, really honest. Back then.
Yeah, but how did they do it? Bazar?
Hey, Chemo, he just told. Hey, hold on. Can I say something? He told you that Aristarchus used 360 degrees from the two wells. So once he did that, he did the 360 degrees. So that was the predisposed
presupposition.
Yeah,
well,
predisposed. Fucking hell.
Yeah, he was saying that it's
that semi and roll the window up, Dave.
Slacker. We're trying to look at Slacker's argument. He's saying that there is a way where they didn't presuppose, and we're just finding out that they actually did. Bazar.
I'm saying the Earth is round, so that's how he did it.
Yeah, they presuppose if the Earth is a ball, then we go over here, then you go over there.
They didn't presuppose.
I wrote a paper about this scheme. I showed it to you.
No, they did. Didn't they measure?
Did y'all hear what I said a minute ago?
Yeah, they presupposed it, David. We got it.
Slacker, you're really low. We can hardly hear you.
Yeah, we need to. I mean, we need to hear your arguments so we can look at them and not just hand wave to dismiss like you see that we do. But if it's based on a presupposition, then that's not.
Hey, Chemo, it's because of the great. They did it with 360 degrees, which is the great circle of the sun around the Earth. That's how they come up. Once you got 360, you could turn it into a ball.
Hey, David, I really love your input with that echo, man. I think you got it going on
David's
real
onto
bad.
Something, definitely. So, Blacker, there's a bit of a problem now then because if everything's presupposed,
fucking hell.
Except it isn't.
Okay,
Regardless
so
of what the people doing the measurement thought, the method that you can use does not require any presupposition of the shape.
it kind of does if you want.
Except it doesn't. You can keep denying that all you want, but it doesn't.
Yeah, but again, it's not like somebody made a measurement and said, "Well, look at the drop or the rate of the curvature." They were trying to fit their maths into the presupposed idea of a globe.
No. It was based on observation, Chemo. Like Aristotle, when he said that he walked too far away from a certain direction and said he couldn't see the stars anymore, so he also worked out that the Earth must be blocking the stars. You know, this is 350 BC.
Yep, so the shape of the Earth was known by various methods. And when you then say, oh, well, we know what the shape is, it therefore must have a radius, and let's go and measure the radius. Now, when you're measuring a radius, that is a radius of a circle or a sphere, and it can't be any other measurement. So trying to call that a presupposition is nonsense, because we admitted in the fact that it's called the radius, the fact that it is a component of something with a circular or spherical nature. We've already determined what shape it is. We're now trying to measure the size.
Again, that is
No. That is what?
Because you're not starting. You need to start with an empirical measurement. So you have force the line.
Empirical observations.
Exactly. You see, what you're missing out, Chemo, is that Pythagoras, Aristotle, and then Aristophanes. So Aristophanes wasn't like, oh, I wonder if it's a ball. He was like, okay, I know it's a ball based on the other people. So how big is it?
Well, that's just it. Again, based on the best way would have been going to the moon with the rockets and looking at it. Okay?
And 350 BC plus.
Well, we did that too.
No. That because the moon the moon landings would have verified what we have been told in all those ancient times. Yeah,
they certainly did.
They did.
That was the point. The point was, let's go to the moon and we can figure out if what we were told is actually true.
The point of going to the moon was to stick it to the communists.
No, because there was doubt still, and there was pressure to see the Earth as a ball. Otherwise, people won't believe it.
Big Cold War going on, don't you remember?
No one really believed it before
America
the moon
versus
landing,
Russia.
Right? It was still
America versus the USSR, the biggest game in the world.
Now, remember the Antarctic Treaty? Russia and America had signed up together. They're friends. They're rich people. Rich kings and queens hang around together.
That's only relevant to the Antarctic. It's got nothing to do with the moon race.
But if you're rich, that 1%, are you going to hang around with peasants? It's got nothing to do with being
rich. It's got nothing to do with being rich. It's all about political idealism.
No, it's all
political
about
idealism.
It's all about having power. And if you're a leader,
the moon race was all about political idealism.
No. All the leaders will work.
It was to preserve, to show who had the best technology, who was the leading nation. That's what the moon race was about.
No. You're not against the Russians or any other nation, are you? You want to integrate. So why would the leaders want to be against other nations? They integrated first, and then the rest of the world integrated.
It's not relevant.
Yeah, but you're saying that Russia versus America, that was never true. There was never versus. That was Rocky.
Of course it was.
You fell up for the Rambo and the Rocky hype.
The Olympics, chess, physical conflicts over territory, Korea, Vietnam. It was all a big political demonstration of political idealism and superiority.
Try to remember, the best Russian players or the best American or British players would have had to play the best players in that country first. So they had Russians versus Russians. Does that mean they're at war over chess? No, don't be silly. It's just that they found out the one guy who was the best in Russia, then they said, let's play him against the best guy in America. But he would have to play against other people in America to find out he's the best. What does that mean, war?
Thank you for supporting my argument. Yeah.
So at school, when people are playing sports, they're at war. They're on the same team.
It is a version. It is a version of war. Yeah, that could be. It could be considered a version of war or way
but
to
not
do
enough.
war,
Not enough to kill each other, right?
No.
No,
you only do that in real war.
The people, the governments around the world, they're all playing sport together. This is a sport.
That's why it was called. That's why it's called the Cold War, because there wasn't that much in the way of actual blood and guts and bullets involved. It was virtually every other means that each side could think of. Like I say, sports, the Olympics, chess, the moon race.
But all the athletes agree to follow the rules. And if you get found out cheating, what happens? You get kicked out.
What's that got to do with anything?
So the point is that the rules are...
You made an irrelevant... You made an irrelevant point, Chemo. What
the rules for this
do?
Monopoly board that we live on are do not cross the wall, the boundary. That's the rules for everybody. You must follow the game, follow the rules together.
There were proxy wars as well.
Yeah.
So unless you all comply, if you try to break the rules, they will kill you.
Nothing you're saying has any relevance or power. There was competition to be the superior ideology.
Way to avoid the geometry topic, Chemo.
I think we've established there is no geometry, right? We're just arguing over apparent locations that nobody can measure.
There's definitely a geometry. You just don't want to see it.
I think you're insane.
You were right. There would be some geometry.
Now, again, you don't have you cannot. So this mountain that we're looking at cannot measure the observer height to that location because it changes constantly.
Observer height's 3 meters.
Yeah, so exactly 3 meters. That would change. The distance that he can see would change daily, hourly.
Yeah, but the height of that mountain doesn't change, Chemo, and you're still missing 2,100 to 2,110 meters. I gave you 2,000, but it's even worse for you, really. So you've got another 100 meters.
If that was
really
physical
bad.
obstruction, I'd be worried. But thank goodness it's just apparent. Thank goodness it will move from its location.
Thank goodness you're denying it is physical, because that water's physical, and you deny water's not wet and physical.
Thank goodness for the black swan observation.
Variations in the physical aspects involved in the exact amount of obstruction seen don't mean it's not physical.
Look at these lines Kosho's drawing, right? These lines are physical, and that position will always be the same. Now, imagine that he's trying to draw those lines, but they change on a daily basis.
Right, Chemo, you need to watch the video. It's got all the information that you can't explain in it. Not just the one picture, but more damaging information. Pretty pictures.
Now, again, show me where the physical...
It's only like, I don't know how many seconds long. It's not long at all. It's really not long. Your attention span should hold out.
It's not. You need to show that where the physical horizon is. That's all.
Why on the day of like hardly any refraction, right? Beautiful atmosphere. Why are we not able to ever see that geometric horizon at 1.22?
Because straight lines of light are going through bent layers of atmosphere. Therefore, there's an angle, and therefore there's a refraction.
And there's not a rule. Yeah.
Refraction.
Yeah. Explain to.
Like it's always wildly deviating.
Right.
Exactly.
There's not a rule that says that it can't be at that position. It's just because of the other factors, it's very unlikely it's going to be at that exact position.
Exactly. And okay, I'm just going to go ahead and tell you, Stacy, so you understand. A geometric horizon is what the Earth horizon would be, and it's a location if we had no atmosphere. But if we had no atmosphere, we would all be dead.
Oh, so there isn't a geometric horizon then?
There is, but we have atmosphere.
But how did you ever know there was one?
Because there's a physical ground we stand on.
So because there's a physical ground you stand on, you presuppose that then, right?
No, it confirms itself when we make observations.
Don't need a geometrical horizon if we're not on a freaking sphere.
When we cutting them off to run your QE script.
Can I just talk to him one-on-one, and if he has a problem with the way I'm speaking to him, he can tell me that, please?
No, it appears you can't, Stacy, because you won't let him finish.
And I said if I was over-speaking him, because we do have really bad Discord connections as well, I apologize, and he could tell me that, but I don't need Curve coming in with his arguments again just to be an ass to me. And I apologize who I was speaking to, Bizarre, if that was you. We can have a decent conversation without somebody else stepping in being rude.
Okay.
Quit being an ignorant, condescending debater.
Okay, thank you. Can I speak back to Bizarre? Let him finish his statement. Go ahead, Bizarre.
I don't think it was me, actually. I think it was you, Davros, wasn't it?
I apologize, whoever it was speaking. I apologize. Go ahead.
Sorry.
No worries. Yeah. So
well, he's all synced off the same hymn sheet, so it doesn't really matter, does it?
Sorry, what, Chemo?
You all sing off the same hymn sheet anyway, so it doesn't really matter.
Oh, please, don't bring me your script and try and talk a high horse route. Anyway, back to you, Stacy. The fact that we make observations on things that we've never seen before, like, for example, we go and we go to a mountain range which we don't know, but we know the distance from where we are to where we need to go to get to that summit. We know the physical distance that we'd have to travel across the ground based on many maps and all the rest of it. that then we could then apply the refraction calculations based on the day and the type of atmosphere we have, humidity, what have you, and see how much of a mountain range we would see or not see. We could calculate how much was hidden using the formula. We could predict, we not confirm, but we could predict. And when we see that mountain range is hidden by that much using the formula we did, we can try it again on another mountain range. And as we begin to realize that that's correct, and we have a plus or minus, margin of error because we're not able specifically to catch. There might be a crazy draft or change, or the sun might be coming up at a certain angle, what have you. But we know thereabouts that the formula works, and so we can go backwards and say the geometric horizon exists because of the refraction calculations working. Now, if there was no atmosphere and we were all in like space suits or something to breathe, there would be no fluctuation of the horizon. The physical rocks, the physical water, the physical everything would be, because the light would be there, but there'd be no atmosphere for the light to bend in. That's how we know. Sorry for the long explanation.
But isn't that still assuming that all this is happening based on what you think that you're on? And in reality, I mean, you guys are going backwards, and you guys are using math for this geometric horizon that would have to exist because of what you are seeing. So you're claiming from what you are seeing, that this has to be a geometrical horizon at 1.22 for a sphere based on what you are seeing because of a mountain and obstruction. But in reality, nobody's even possibly figured that maybe that obstruction that you're seeing is coming from something different than what you guys claim.
Well, Stacy, here is the thing, because by the fact that it's moving, we know that that is an optical phenomenon, right? Nobody's saying that the actual surface is moving, right? It's literally moving because of optics, right? So we know that much, and we pretty much know that if things go over it, like say we put a lamp post and it goes over it, it tends to go down. That light on it goes down and down and down the further we get away. So there is some indication that it could be curvature, but
But when we can bring in a boat, and we know we can do that, I can do that right now, and we can see stuff that goes closely over this, horizon, and now there's this drop. But then again, in reality, we bring it right back into view, and it's never, ever happening, even at 10 miles. Where is this geometric horizon? Why would you guys even believe in it? I'm confused here.
That is the phenomenon. That is the optical part. You see, what we're saying is that the optical...
Just bring back into view in house, or...
The ship's over the horizon. You guys see the ship really disappears? But it doesn't disappear, right?
Yes, it does.
No, it doesn't disappear. We can pull it right back into view.
No, you can't.
That's what I thought you said.
No, you cannot.
Your physical horizon is where? So it should be what obstruction when? And when should we no longer see the boat at all?
No, what we are saying is that there's a curvature and it will obstruct things, but at times the optical conditions will make it obstruct more or less.
Okay, if a boat's 10 miles away from me and I'm on shore, it's 10 miles away from me, I should not see that boat, correct? Or at least should be seeing obstruction. How much obstruction? How much? 60 some feet?
You haven't given us enough info.
Let's try the black swan because you're familiar with that one.
Well, we can go to that, but I'm just asking you a simple question. In reality, 10 miles.
I need it for this example to explain how we see it work.
Okay.
So if go past the whole motor tolerance and all that. What we're seeing on that, and I built those platforms like that for the windmill farms. Those legs on it, they are good 10 meters out of the water. That's like 30, 40 feet or something before there is a deck at all. And what you see on that is that the horizon, the horizon that you see in the actual Black Swan image, is well above that 1 foot observer height because it's way up those legs. And now I'm sure you don't believe the Earth is concave, and I don't for sure. So how did that get up there, flat or around? How the hell did it get there? It can only ever be an optical effect that is moving it, right?
I don't want to make you have to repeat all that again. I just have my little godchild walk in here, and it's too much. It's too loud. I did not hear most of that. I apologize.
Oh, it's fine. I'm asking, how did the horizon on the Black Swan get above the observer? Because you don't believe it's concave, and I definitely don't. How did that happen, if not optically?
Why is it concave?
Because the horizon is above the 1 foot observer.
So now we're assuming that we're concave because of what we're seeing in an apparent place in the phenomenon. That it have to be a concave Earth now? I mean, why do we presuppose anything? And how do we even know how things would work on a flat Earth if we don't even try to apply that?
Stacey, we're not assuming it's concave. We're very sure it's not concave.
I mean, we're going to have a horizon if it's flat, guys. I mean, it's what? Are we not going to have any atmosphere at all? We're not going to have a sky? It's either sky or ground. Are we only going to have one or the other? We're going to have a horizon, flat or not.
Daisy, with the whole little girl and all, don't get like that. You know, we're doing this nice and easy. That horizon most definitely moved. It's higher than the observer. And the only way it can be higher than the observer, flat or round, is by an optical illusion, right? Because I don't
everything that we're seeing right now is almost an optical illusion where it's at, how far it is, if there is refraction, and we don't know how much refraction. We have to take all that into the equation, the atmosphere. I get all that. But in reality, like I said, the geometric one, that it supposedly exists, that is physical, that is 1.22 supposedly, it's never, ever been verified or seen, yet we say it exists. Based on mass and a ball from our observations of supposedly this radius in Earth that we're living on. In reality, no one has ever listened to me though, please. No one's ever seen the geometric horizon. We just assume that that's exactly where it's supposed to be for this massive ball.
Distance. Calculated distance based on the known radius of the Earth.
Run in with this. Now, if you have something that you get an inconsistent observation of, like anything, you know, if you go and look behind your car and the blinkers doesn't work when you're outside of the car for some reason, you know, you'd have to look at it some other way, right? You can't just go, I'll try again tomorrow. Yeah. You can't just go to the same location and say, oh, it doesn't work again. Well, no.
Well, yeah, the thing is, that's insanity if you keep repeating the same thing and hoping for a different result, and it's, you know, it's insanity.
Yeah. Exactly. So why are we getting back to these low-level observations every time with the flat Earth? Because if we did all this from 2,000 meters high, you would have a very consistent horizon. It wouldn't move barely at all. How did that happen?
No matter where you get and view this horizon, you're never seeing the geometric. You will always see an apparent one, no matter where you view it. So my problem is, as a human being, we've all said a geometric one exists, but in reality, we've only seen the apparent. No one's ever seen a geometric, but we're just basing this geometric one existing and a ball based on what we've observed, supposedly, of this Earth. But in reality, no one has ever seen a geometric horizon because it's based on the mass for that globe model. That how it would work, where the horizon geometric would be for this sphere that we're supposedly on based on this radius that I don't even know where they got from. Because in reality, we're basing it, on a radius that they just made up? But I know you guys don't believe that. Listen, I understand. I know you guys don't believe that. That's my belief and my knowledge.
The problem.
But you guys can admit you've never seen a geometric horizon. No one can ever film it, see it, picture it, or anything, but it exists based on mass.
We understand why you can't see the geometric horizon. We're perfectly comfortable with it. It is not a proof. It is not one of our proofs of a sphere.
And how far off is what we see?
But a geometric horizon is how we all started with this sphere.
No, it's not.
I'm sorry. You're basing a radius in a geometric shape based on a horizon and a geometric horizon.
No, you're wrong. Stop saying
that's wrong. A straw man that we've never acknowledged.
You're on a ball, right? We're on a spinning ball, a geometric shape, 3959. But 3959 is some accurate measurements, right? That we supposedly don't have accuracy at all on the Earth. We said that earlier. There's really no accuracy of anything we said. So in reality,
you only give us 4 digits. So yeah, it's not accurate because it's only 4 digits. If it was accurate, it'd be an infinite number of digits, wouldn't it? But an infinite number of digits is absurd. So stop being absurd and just stick to the real world.
Infinite number of digits.
Okay, can I be honest with you, Stacey, about what QE or whoever, that argument about the, because I've heard this, you've heard me and QE talk about this because he uses as an argument saying that we have the horizon and we use the distance to the horizon and reverse the math to come up with the radius. But I promise to you, it's not how anybody does it. It's not how we claim that it's done. It's the other way around. We can infer where the geometric horizon should be based on where we've calculated the radius to be. But we would not think that we would be able to find what the radius is by first finding the horizon and then re-engineering the math to go back to the radius. So it's a, what do you call it? It's a straw man to say that.
How exactly is 3959 measured and from the get-go? And especially if you talk about those surveys, the survey says it's based on presupposed dimensions. I want to know where those presupposed dimensions are coming from for all this new survey. And especially when you put it in. No, I'm not saying anything for that shit. It literally says it in, you can Google it, and we've already been through this before. It is based on presupposed dimensions. It says it on Google even.
It says previously known dimensions, not presupposed.
Right, and you need, well, okay, isn't that the same thing? You're based on dimensions that were, yes.
For fuck's sake, woman, words, learn what they mean.
Where did you get the dimensions in that?
Hold on. I'll just clarify. It said also that during these geodesic surveys, they all had to compare them with each other, and they all had to be in alignment with each other before they were, signed off as accurate. And one of the French survey teams that Jim put you onto did for 10 years. They worked on their observations to get their measurements. And so it was previously known once they were in accordance with everyone else's measurements, then they were used. So it's not just a presupposition, it looks like this, looks flat type argument. It was measured. Physically measured.
And I can post it again. And that same thing says there, for calculating it and putting it into your program of calculations, you literally are basing it on a ball of dimensions that you already knew prior. Yeah. Where are those prior numbers coming from before you even went into looking into this survey?
Measurements
of how and where, when, all
geodesic surveying of physical ground.
I'm talking about before that.
Well, Stacey, that's where we start at. I told you there was 90 times 60 nautical miles from the pole to the equator, and there was 2160 nautical miles around the equator. 21,600, sorry, my bad. Those are measurements. Those are known. Those are navigational facts.
When were these measurements of the entire Earth taken, and do we have any proof of them, and any proof of them actually being done? Anything, all over. Well, before these surveys.
You're an American, aren't you?
Of course I'm an American. Mm-hmm.
Yes, and you're a white American. So you came
Well, it doesn't really matter if I'm white or not based on my voice, but it doesn't matter.
No, but essentially you came from where I live, or your great-grandparents did.
Right, my family's from Liverpool and Germany and UK, yes.
Yeah, so pretty much where I live. And they got to where you live using a sextant, using the fact that I just stated, the measured known navigational fact. Well,
right.
Maybe not personally, but somebody did that.
And that Christopher Columbus and all this stuff. I don't believe in that history that we were taught in school, and it's been proven. And even kids are taught nowadays that Christopher Columbus didn't do this shit. So in reality, did anybody do any of this stuff that we're claiming? Is there any proof for it?
In actual reality, I have in my family, a family heirloom is the sextant used to sail a sail ship from Denmark to the US, to the Virgin Islands, they're called now. They were the Danish West Indies at the time. And they sold them. They sailed there from Denmark using a protractor for the skies and a clock. And they got there.
and then they sold the friggin' islands to your country. And they got there fairly consistently because it's chock full of slaves that we were selling to you guys before that.
Well, they traveled, right? And they didn't know it was going to happen. They traveled, they got here. But just because they traveled from one place to another does not mean that they have traveled this entire Earth and they understand the size and dimensions of this place.
Well, it does mean they have a very consistent way of getting there, doesn't it? You know, you can't just sail somewhere and just sell your slaves as you fall on land, now can you? It's going to need some sort of consistency, isn't it?
You kind of can in ways. I mean, people did do that, I'm sure.
Oh, that's not how we roll, you know? We had a place where we picked...
Why not? People were willing to go to space, you know what I mean, with no understanding, they said, because they want to do it for explorations and not know things. So why wouldn't they just get on a boat and say, hey, let's see what we find, let's travel? Of course they're going to do that, supposedly, right? Without having any knowledge.
Yeah, that's what you do the first time, but you want to get back to where you landed the last time. I.e. to your own damn islands, such as the ones we sold to you. For $100 million, by the way.
Isn't it interesting?
Yes, very.
We can agree on stuff like that. We could talk about that history. We could definitely agree on things like this.
Well, you know, there's a reason we got there fairly consistently, and that is, you know, because this navigation stuff seems to work.
But circumnavigation, we can't figure out how to navigate differently than what they've already told us based on a presupposed ball. Is there another way to navigate outside of what they're telling us? I mean, that's what needs to be taken into the equation. Do we really know how far one place is from one country to the next? Are the maps actually accurate? No.
Yeah. Yes, they actually
not.
are.
Even the flight patterns are off. You cannot verify where that plane is traveling and how they traveled, and it could have been done in a distance that was shorter or whatever. You don't know.
No, you're just trotting out more flat Earth propaganda. You haven't checked this for yourself. You just
literally, this is what stuff that I've researched too. Don't tell me that I'm popping out propaganda of research that I've done.
Faulty. Your research is faulty. The thing about flight times is completely bogus.
So you can verify and tell me that every time you go up in a plane where you're going exactly where they're taking you, and they couldn't have taken you to a different path that would have been faster or shorter. I'm sorry. No. Or longer?
No.
Yeah, why not?
Planes are annoying because they go in the skies, and the skies have winds. But you know, boats are fairly consistent because they go, well, on the water, and the water is pretty much going to be where it is. And the reason that we know it's 60 miles to the degree around the equator is because that's how we navigate it. 60 nautical miles, it's 69 miles of your miles. You know, you could go someplace in Africa and drive along the equator and measure that 60 miles to the degree if you wanted to. Easily. You'd have to go to the equator, and it's a shitty place because there's civil wars and shit, but, you know, you could.
And also, what you could do once you've done that is you could set up two parties to then go north. One party go north and one party go south of the equator, and they will notice that the physical distance between each 1 degree longitude becomes smaller the further you get away from the equator, and that is only possible because the Earth is a sphere.
There's actually a test I'm working on with a few people.
Yeah.
Indeed. If you go east-west, south of the equator or north of the equator, is not going to be 60 miles to the degree, which is, in fact, globe evidence. It's not at all 60 nautical miles where I'm at. I'm like 47 north or something.
Yeah. All the lines of longitude meet up at both poles, the North Pole and the South Pole. The distances between those get smaller.
This can be emotional, guys, because you guys are lying to us.
Nobody's being emotional.
You're not giving us the evidence we asked for. You're just giving us a story.
You can verify this for yourself. It's not difficult.
Yeah, but you haven't done this, Bazaar. That's why. You're just saying a story that you think has been done, and that's not how you go about discerning the truth.
You've not done anything, Chemo, except tell lies and make up deceptive videos.
What are you doing right now? You're lying to us. You're giving us a story about someone's been here, been there, measured this. This is all false information.
People have done this.
Right, prove it then. Show it right now if you're not lying. Show it right now.
No,
No, you won't, because you're lying, you're deceiving, and your deceptive tactics
and they've
are
noticed
making
that the
flat
lines of
earthers very
longitude
wary about your
change physical
information.
distance exactly as they do from the north.
You're
in the
just
northern
waffling
hemisphere.
on, lying to us. Where's the proof?
So, northern hemisphere, southern hemisphere, they're both hemispheres
nice
of a
story.
globe.
Prove it.
The test that I'm working on with people.
Yeah, thank you. Well, a test that you're doing now doesn't. No, sorry, Coach, I'm going to cut you off, honey. A test that now does not prove what you guys are stating now and claiming that it has been done already. And there's a lot of these things that supposedly have been done. Yeah, I've never seen even documentation even to prove that these things have been actually done. So you're right. Where is the documentation like Chemo's asking for, the claims that are being made?
What claims?
That it's been measured. Where's the measurements?
Yeah.
Who's measured it?
Every map of the southern hemisphere that has longitude and latitude calibrated down the sides of the map and is projected with a certain distance per inch, you can confirm that the lines of longitude come together the further you go south.
But where does somebody measure this? Where's the proof besides a map? I don't want a map that I don't even believe is actual factual. Where is the actual information?
A map is proof that someone made these measurements.
Yeah. Each country does their own
I can make a map. Does that mean that I've done these measurements? No.
Yeah,
where's the proof that I've done it?
Each country does their own measurements, and every certain amount of years they update them for accuracy and check them. And a lot of the time they don't change. The only time they change is when topology changes, erosion of mountains, etc., and the slight moving of continents. But you know,
these measurements are repeated.
Yeah,
okay, can you show me where they're doing them and show me the proof that they're taking these measurements, how they're taking them, and let me see that, please.
No, you
every
prove
day
that they're
or every year or whatever.
No, you prove that they're not correct.
What's correct? I haven't been given any information showing me that they're actually doing this, and until then, it's not correct.
We're not going to give you information. We are telling you.
We're just going to claim it that it happens, but it's never happened. Your proof is, hey, we've done those measurements. Hey, you don't know what you're talking about. Yet I'm not going to show you that it's actually happened.
From nowhere. Maps didn't appear from nowhere, unlike
because we have maps, we have a globe now. Because we have maps, we have a radius now. Because we have a fucking map, no, excuse my language, I'm sorry, but because of a map that I can, you know what? The whole world could be reset right now. And I could print out a map, and guess what? There's your reality because I made a map.
Yeah, there's the maps.
Where is the proof that you demanded from that person who made the map? Where is the proof of the observations that was done for that map?
God,
the body of evidence.
I have a perfect example.
That the Earth is a globe.
I have an example for this. You see, recently there was a flat earther in here claiming that Australia was floating around. And I was somewhat skeptical. And then he provided evidence that Australia is indeed moving. It's moving by about 3 inches per year, northwards. And the very fact that we know it moves 3 inches per year northwards, making for a correction of 4.9 feet in 20 years, by the way. The only way we would know, to correct it by 4.9 feet ever would be that we pretty much know where it is. Right, Stacy?
No, I want to see proof of where it is every single time, and you should be able to show me that, and it should be the same every time you measure it.
No,
right?
You go find it. You go find it.
I'll go find it. You don't have to show anything they're claiming. That's fine.
Besides, if you make up a map and it doesn't match reality, don't you think somebody's going to notice? You can't just make up a map. You can't just. I'm not finished. You can't just make up a map and claim that it's reality. You have to actually measure things, and people would notice if it's not correct. So unless you can tell me that people have noticed that these maps aren't correct, then you don't have any claim.
Okay, I can actually make it correct, though. See, all I have to do is basically measure what I can actually see, because it keep the world away from the rest of the people, more land from people, and all you have is this to measure. And now you're going to believe that this is what you're on, and then to make the maths work around that measurement. But in reality, guess what? There's more. Wait, can I finish too? Maybe there's more land than you're being told, and you're not even verifying it because you're going to believe a map that was given to you that maths work with. I could do that too.
Maybe people have actually measured the distance between roads and landmarks. Then they've actually gone out and done those measurements, and that's what they've made the map from. Like I said,
it's not a good enough answer.
I'm not finished. Like I said, if people would have used these maps, they would have noticed if things weren't in the right place. So the maps are actually made from the measurements. So don't tell me that the maps are wrong. And don't tell me that there could be, I'm not finished. Don't tell me that there could be land that we haven't discovered yet, because people have explored pretty much everywhere now.
You
and they've measured out and mapped out.
You've been to Antarctica, right? You and your family.
Yeah, I have actually.
To Antarctica. I've been there twice. Seen it all.
I've been there twice, Stacey.
How? When?
I've been there in 1982 and earlier this year.
How did you go there, and how did you know you were there in Antarctica?
I went by boat.
Okay. And you were there for sure, observing the entire time how you were traveling, where you were going, and you were in Antarctica, and how long it took to get there.
Stacey, that's
I'm asking you questions. I'm not saying you're wrong. I'm asking you. So you did that, right?
Yeah.
You're in Antarctica.
Yeah.
How far did you go in Antarctica? How big is Antarctica?
He's from
How
Australia.
was the weather conditions?
What?
How was the weather conditions the further you traveled into Antarctica? Have you seen it all? Have you observed it?
Well, it depends on the time of the year. I haven't been all over Antarctica, but I've been there.
Of course, nobody, no one, no American, anyone in the world.
Did she drop?
I think so. And Paul, did it take
you cut out there?
Paul, did it take as long as you expected it to take from the place you left to get there?
No, about the right time.
Right. So now Antarctica has to exist in a location by boat from Australia, which is, as we can agree, and all flat earthers will agree that Australia exists. Don't cut me off. Australia can exist because we can go there. So now, Chemo, do you hear that? You have to factor in that Antarctica is the distance from Australia to Antarctica by boat as we know it to be.
Look, I've sent you the map here, and there are two locations to get to the ice wall. You can either go from Argentina or from Australia.
It's not the map. That's a projection, as it says on the map itself.
What we're asking is, if once Paul got to the ice wall, to the edge of the Earth, did he continue on and go deep into the ice, which we say you're not allowed to, and then obviously come back around the other side? Of course you go to the ice wall, Paul. You're right next to the ice wall. Why wouldn't you be able to go to the ice wall? The idea is, though, can you go
There was no ice wall where I was.
Yeah, well, you just went to you probably just went to the look at the flat Earth map, and you'll see you're right next to the ice wall. And we even
there was no ice wall where I was.
Well, they probably took you to another island.
You didn't travel everywhere, so.
Chemo, your map says flat out it's a projection.
Yeah,
it's scientifically accurate.
All maps are,
except for ones on. Digital navigation.
The idea is that Paul's near the wall.
I've told you again, there was no ice wall.
The only way to you didn't go to Antarctica then. The only way to prove
it. Yes, I did.
No, you didn't. If you didn't see the ice wall, you didn't go to the actual Antarctica.
There isn't an ice wall all the way around Antarctica.
Why you didn't go to the edge then?
There is no ice wall.
We've got the map, Paul.
Chemo, on your map, what other great big-ass ice mass can you go to from Australia in an hour by boat?
Australia's right by the ice wall. Look at the map.
No, South America.
Yes, and seeing as there is no ice wall, Chemo, where did he go to then? What was the ice he was seeing?
He didn't go to Antarctica then. He just went to some.
Do they have a mock-up Antarctica out in the ocean that these sail people to?
Yeah. What's the other place I went to then?
Did you see an ice wall? Did you see an ice wall?
I don't know why they deny the ice wall, Chemo. It's just the coast of
I don't know why either. Either he went to the ice wall or he didn't.
The map's wrong anyway. Yeah, Australia is not that wide.
Exactly. what is it, like 4,000 kilometers too long?
There's so many things wrong with that map.
Yeah, New Zealand looks like a. Yeah, I'm not gonna say it's not what New Zealand's shaped like.
No evidence of an ice wall. Australia's not that wide.
See, the problem is that
across the ocean are too big.
Because people can drive it.
People can drive it, but people haven't driven this distance and shown that it's not the same.
You don't even know what the roads are like, Chemo. You drive around.
What do you mean,
drive around the very edge of Australia, Chemo. Do you have a
I'm
clue?
saying that. How do you know?
Do you have a clue?
How do you know?
Have you crossed the Nullarbor?
How do you know this map is
I
wrong?
have.
So, Kimo, is that a large movie prop just floating around outside of Australia? How does that work?
How do we know the map? I don't understand what you're arguing with. Show me what you have so I can compare it with this map. What are you comparing? What are you comparing it with?
Australia, literally around it, like I've
compared it with.
What are you comparing it with? What's in your mind or a real projection?
The odometer in my car.
Everybody's daily experience in Australia.
You're comparing it with everyone's daily experience.
All the dimensions,
no measurements.
All the distances work every day for everybody. All the distances, all the travel times work every day for everybody who lives there.
Again, this is just a story. Where is the map so I can compare it with the flat Earth map? Where's your map?
It's verified every day by everyday people, and that map is known as a equidistant azimuthal projection. That means the only truth you can tell from it is the direction from the North Pole and the distances along those cardinal lines away from the North Pole. All other measurements are not valid. And that is implicit in the type of projection that map says it is.
Yep.
You don't have a map. I don't understand what you're comparing. I don't understand what you're comparing it to. What are you comparing the flat Earth map to? To what?
The odometer in my car, mate.
To something in your car? What, when you drank beer?
The odometer.
What are you comparing? Show me your map and let's compare it to the flat Earth map.
The odometer in my car.
When you drink, your odometer
you can make flight patterns and all this shit work around your model, any map, anything. We don't actually know. Even the flat Earth side has absolutely no clue what's going on this Earth.
Can't.
It doesn't work down in Australia.
We don't have a radius, y'all. You can try to think if we do, but you don't know the measurements, the true measurements of this Earth.
All right, I'll ask you a question. That I was going to ask Woodsit, but he ran away. Why are there two types of sundials on Earth?
Hang on, I'm cooking too. Hang on.
Is there only two types?
Yep.
That's all we got. Two types of sundials.
That's right. And here's the thing.
So why are you asking me? Because isn't a sundial based on what somebody has literally done on Earth and made up for what they see in the parent location? That doesn't help me figure out the radius of my Earth.
Unless you say that we control the sun.
I never said we control the sun. The sun works in a certain manner, and it continues to work that way. And it will continue to work that way more likely.
That's right. So if I take a northern hemisphere sundial, one that accurately tells the time using confirmation by analog clocks, digital clocks, and cell phones, and I take that northern hemisphere sundial below the equator to the southern hemisphere, why do I have to flip it upside down to make it work?
Okay, so the different types of sundials are northern. The different types of sundials are northern hemisphere and southern hemisphere. That's it.
Yeah.
Jumping from topic to topic,
you're
losing your globe. And
we're just dealing with the northern hemisphere working in the south, and to do, let's just start there. I have to flip it upside down to make it. I have to flip it upside down to make it work. Why is that?
Are you going to concede at any point, Sheeple, at any point? The horizon's not physical now, yeah?
When I lose one,
I'll posting something in the debate chat box. There's multiple. There's like 6 or 7 different types of sundials. I'll just post it in the debate chat box real quick.
Right, but it doesn't.
Yeah, but I'm asking why do I have
even
to
if you
flip it upside down?
Because it's probably made a certain way, right? But you're going to tell me when you go to the southern hemisphere that you're seeing the stars rotate in a different direction? that what you're saying?
Definitely.
Prove that shit. Because let me tell you, it's how you're perceiving it and your angle.
No,
Can you prove that stuff, Sheeple?
Okay, show it to me. Prove it to me. Prove it to me.
It's a physical thing you see.
No,
Prove
it's
it to
not,
me.
Sheeple. It's an illusion.
It's not an.
Well, then prove it. Then let's see it.
All right, you muppet. I will.
It's an illusion that the southern hemisphere has and the northern hemisphere doesn't. Well, that doesn't make sense.
Remember, you see things apparent.
This is
not
gonna hurt,
actual.
Stacy. All right, this is gonna hurt.
Okay, it can hurt. Nothing really hurts me that you think it does, because I'm here to talk about the shape of the Earth, and that actually does matter to me, but it doesn't apply
Not
to
you
hurting.
physically. Your argument. It's
Okay.
gonna hurt your argument.
It doesn't hurt me, honey.
It's ridiculous, Stacey, because you could get so many eyewitness testimonies that there's the southern
Well, then where
center
are
of
they?
rotation.
And it does have to matter on perception and where you're perceiving and your angle, and all those things have to go into equation. Please show
It's so
me.
well known.
me.
It's so well known that people don't even think it's required. It's only
So
loonies
well
like you
known that
flat
nobody
earthers.
knows about it.
No, everybody knows about it. That's where you're wrong. Everybody knows that this happens.
I watched
Because
it
it's
out
just
my door.
Can I
Stacy.
see, please? Can I see,
Yeah.
please?
Sure.
Thank
I
you.
watch it out my door. And here's the thing. I just got another camera today. So I'll be filming my skies here in New Zealand a lot more as we move into summer.
Please do that, actually.
I
Everybody
will.
does.
Are you going to concede
And I'm
that
not being
there's one or two
sarcastic. I'm
types
actually
of
being
sundial?
sincere.
No, Jeremy, what I talked to, you may talk about the different types, but what we're talking about is a sundial not working in the southern hemisphere. If it's working in the northern hemisphere, I have to flip it upside down.
Show
that
me, but
was
also
the
is
thing.
it because of how it's made? Maybe it's done that way on purpose. Can you please show me how it's
to
made?
do
What
with
sundial
the
you're using and show me it
sun.
working like that. Thank you.
It's to do with the sun. And now what Crash or Dr. Oh my goodness, great, look at that name. Dr. Zora, he is showing you a 3D printed sundial. Now the same premise applies here. There's a northern hemisphere version of the 3D print, and there's a southern hemisphere print version. And I have those files on my computer as we speak. I even have the pictures to show you that the versions are different. So if you printed a northern one and sent it to me, it wouldn't work. If I printed a southern one and sent it to you, it wouldn't work. You have to explain on a flat disk pancake pizza Earth why that is a thing at all. If the Earth has got one sun and it's circling us in a track, that's a problem for you. Now, allow me to present the hemisphere.
I want to say on my end, if you don't mind, as a flat earther, and I state this, I don't know how our sun works, and I think that it's wrong to even assume that our sun would do the same thing all the time. 2,000 years, how do you know what's going to happen, what's going to react, and what's going to go on? So for me to say that I know how our sun works or how close it is and all those things, no, I don't state those things as a flat earther. I don't know apparent locations. I don't know they've been here for 2,000 years.
Yeah, well, if you don't know that, how can you say it doesn't work what we already have?
Stacey, you can't present your ignorance as any kind of evidence.
Here you go, Stacey. Here's
I never
Peter
said
Harrington.
it didn't work. Those words never came out of my mouth. I said it works if you want to base it on something that you've made up and mass and a concept. You can make anything work.
No, the digital sundials.
Show me how you can do that.
You
Post
can make
the
a
video.
concept, make anything out of anything to around. Okay, you have a certain situation and you take mass into the equation and
You put
figure
some
out
maths
to
in
make it around that concept. We're not trying to figure out mass for what? What am I trying to figure out mass for right now? Come on.
We'll put some maths in the
But in reality,
chat
you
box that
can
shows
make
how
a
it
concept
works.
and put mass around it to make it work for you.
What maths would you put
can.
around it?
Yeah, that's
I mean, if maths
I
was
mean, you're
useful,
talking in general terms.
we
What
would-
about some detail?
You know what I mean, but you guys
use it.
have to go down the little patterns
I
to
don't
get
know
all
what you
subject
mean.
to not stick to an intellectual, serious conversation. Instead, you want to go down these patterns of stupidity.
Maths is
that doesn't
used to
even, it's not even
describe
needed.
it, you know. Maths is used to describe it.
Exactly. Thank
It's
you.
a language.
Right,
It's a language
It's
like
a
we're using now.
description of what you're observing and seeing. It's not reality.
right.
Math is made
Thank
up
you.
by man.
Exactly.
hold on.
Thank you.
Stacey, before it
It's
gets
a
too far
description.
away, the video of the Star Trails by Peter Harrington is in the chat. Note, at around 20 seconds on the left-hand side is the Southern Cross. You never see the Southern Cross. Funny that. Thank you. And notice Clearly, the trees are not growing out of the sky, so now we know the orientation of the stars is indeed moving the way we claim it is.
The trees are not growing out of the sky, so therefore we know. What?
So
did you just say that? I'm so sorry. I apologize, but my brain just exploded.
Well, let me explain to you. Every flat earther tries to say, well, maybe your camera's upside down and you're just lying. Well, the trees don't grow out of the sky, so now we know the orientation of the camera.
Okay.
Yeah.
Okay.
Yeah. I thought you might have been able to get that, but...
No, I haven't heard anybody say that. I'm sorry. I'm like, what are you talking about? I actually thought you were making a claim. I apologize, too. That's okay. Now we're on the same page.
Fair enough.
People, please don't use that word Muppet. My father was a Muppet.
But Chemo's a Muppet.
Have you got a hand up your ass too, Kosho?
Yeah, bro. His dad, the crushed velvet started to peel away on him. It was terrible.
Why did you guys tell me fucking Jake was awake?
When the fuck did he get here? Oh no.
Hey, Kosho, was your dad one of the old guys in the Bannister?
Alright, I'll always say Muppet when you're around, Kosho. I'll only call Chemo Muppet when you're not here. Deal?
Say Chemo?
Muppet.
Yeah.
A offensive term, you don't mind me asking.
That's right, JJ. They are derailing.
They're
looking for a breather. We've got these guys like underwater, and they're like, "Gosh, we need to breathe. There's too much for us. Stacy's absolutely destroying us. Too many questions."
Chemo, Stacy's watching the video. Stop lying to everyone.
Right, and then obviously,
was it video?
No, sorry.
Yeah, Peter Harrington, Southern Hemisphere Star Trek.
Sorry, Chemo.
Yeah, but is that from somebody else? You said that you can do this. Oh, sorry.
No, I said I just got a camera again today, so I can do this.
So what?
Buna, you can't be heard.
Yeah, I can't hear who's talking. They're kind of cutting out for me. I don't think I have for you.
You're all muffled, Boonan. Sort your microphone out.
What?
You calling him Boonani?
Sort your microphone out, Boonan. But
who's Boonam?
This is what they do, Stace. When it gets too much, they look for ways out.
Here we go.
They look for how can we avoid, how can we maneuver onto something else. Instead of just conceding, sheeple, why not just say, okay, you've got me. Don't have geometry. We can't figure out the rotation. We can't figure this. Why not just concede? Why go through?
Why not concede? You can't tell me where the mountain went.
Well, we spoke about.
But that's not even the point of trying to prove anything.
Oh, okay. So I've got to concede
to something. You're talking about one. No. I don't want you to concede on a mountain. I want you to concede on reality that we are giving information that we really don't have actual evidence of. We're just basing it on data. Data. For me, data isn't enough. Especially when you're given numbers like 66,000 miles around the sun, and you guys are given actual measurements, and yet nothing can be verified. That's a big deal to me. How many light years away? How the hell are you figuring that out? And then they go, well, we don't really know. It's apparent we don't know the location, the distance, but you're claiming you do. That's a problem.
So how about those stars?
Redshift.
How about the ground that I'm standing on? How about this big ball that's spinning on this supposedly Earth is rotating underneath me, right? It's rotating underneath me, the same stars that exist all the time.
0.0.
Everything that happens every year, right?
417 degrees per second. Would you feel that?
Why wouldn't I feel it?
0.00417
See, your math and your science and your bullshit, not you, the bullshit explains you're not going to feel that. But in reality, would you not feel that?
No, you
we're also moving 66,000 miles around the sun.
If I was stealing your wallet in a rotational fashion, if I was pickpocketing you at 0.00417 degrees per second, you would never know your wallet was gone by the time I had it.
Is the Earth rotating at different speeds?
Not weak. It would take you. Yes, she would probably figure it out. What you talking about, Willis?
Pickpocket someone in a rotational fashion.
Yeah, I know.
Well, if you think about it, Jeremy, if I spun my hand and her wallet was there and I kept going, and passed it on a perfect circle, that would be a rotational fashion. Something I wouldn't do.
You're saying that if she had a gyroscope, she would detect it, yeah?
Come on, people. You got
Damn, I think I got to concede on that one. If she had a digital gyroscope, like let's say the ring laser gyro that Bob, thanks Bob, used, then yes. And she was watching the screen, she'd be like, "My wallet is moving." Very good, very good.
I think you have one of those up your ass. I'm thinking you would notice more than just it moving.
I think that was a valiant effort.
That was pretty good, Chemo. Now I don't believe you're a flat earther.
But I do have a useful something you can take from that is the number that he gave you. To be honest, I don't remember what he said. That number is a very small number, and we discovered yesterday. Some of us discovered yesterday that there's actually a value to the minimum threshold that your body can actually sense as far as acceleration goes. So your body can only sense threshold that is at least bigger than a certain amount. And I think that amount that we discovered yesterday was 0.1 meters per second squared. Whoa. So if it's above that, your body can feel that. But if it's below that, 0.1 meters per second squared.
I mean, it comes down to trusting your senses, doesn't it, Stacey?
Your body's too sensitive to feel that.
That's interesting, Kosha. That's really interesting.
So, yeah. That little minute rotation, I'm not going to feel. I honestly, I'm just being real here. I call bullshit.
How much data do you actually have proving that we wouldn't feel that? Was this one study or hundreds of studies?
Percentage, our buddy, percentage, your buddy. Some of our buddy.
And I'm not calling anybody in here bullshit. I'm claiming that we're not going to feel that shit. BS.
That's okay. There are bullshitters in here.
It was a basic calculation I did.
Yeah, percentage actually pulled it up because he didn't believe me either. I told him this number, and he's like, "I'm gonna go look it up." Actually, he told me to look it up. Then he went to go look it up, and then he came back and he said, "Damn it, you're right." Well, he didn't say that, but it was the same value I told him, and it was 0.1